Again for another day of Odinmade Hero. My own little spin on Handmade Hero. I'm just going to go ahead and jump right into the Q&A for day, what day was I on? 27, and see what I can learn from that, and then probably poke around in the code that we wrote yesterday a little bit and make sure that I understand what's going on. I'm not totally happy with the end result, the implementation for writing those pixels out in the frame buffer, but we can refine these things. We can make them better as we go on. So let's go ahead and jump in.
Pushing the Q&A button now. So if you want to go ahead and ask a question, please keep it to stuff we did today or stuff we have done in the past. And I added some new features to the question. So from now on, you should be able to just put capital Q colon and then whatever you want, and I should see it. So you can try that instead of Casey Muratori. Never been tested, but hopefully it'll work. Let's see. D. Mitsuki said in the past, and I added some new features.
I neglected to let the video reload again. Whoops.
To the question. So from now on, you should be able to just put capital Q colon and then whatever you want, and I should see it. So you can try that instead of Casey Muratori. Never been tested, but hopefully it'll work. Let's see. D. Mitsuki says, what is that fatal link area when you compile the code? Am I going to die? No. So what happens there is, if you remember the way that we did the build, we build two things. We build the game code as a DLL that we can hot load, and then we do the platform layer as a separate thing. The platform layer is what's always running in the debugger. So the debugger has the executable locked, and we can't write to it. So this succeeds, this first line succeeds, but this line will fail. And we don't care because we're not actually changing the platform layer. We're basically only ever changing this code now. When we want to change the platform layer, we have to stop the app. But until we change the platform layer, we don't have to. What this fatal error is telling us that is, hey, I did the recompile step for the platform layer, but I can't write to it. And we're like, that's fine. We don't care. We only wanted you to build the other one. So that's it. That's all that is. What sort of things do you think are good to include in a portfolio when looking for a job? I'm a student looking for his first job and would appreciate any advice. So I guess what I'd say is that come back during a pre-stream. Basically, like for 10 or 15 minutes before the stream starts, I answer questions that aren't about the code that we're doing. So if you want to ask that question, come during a pre-stream and we will, and I will answer it. Randolph, Q colon, does this work? Yes, it does. Hi, technology. Rogue creature, I see you. Mgarp, see you too. So this is good. We are good. Gary Johansson says, thoughts on refactoring this to be all functional programming? Well, I'm not a huge fan of doing things dogmatically, and I feel like refactoring an entire game to be functional programming is a bit dogmatic. Now, if you're just doing it as an exercise, then any programming exercise that suits your fancy is a good exercise, right? Even the worst possible programming methodology, like I really want to write this in lots of crazy C++ inheritance. If you're just doing it to see how it goes, that is a great idea, right? If you're asking whether I think it's a good idea in terms of productivity, I'm probably going to say no, right? And so thoughts on refactoring it all to be functional programming, I'd say, well, why are you doing that? On the other hand, as I've talked about in the stream in the past, I do think that functional programming is good to do in places where it makes sense. Basically, like there's a lot of things, I tend to push code towards functional when I can. I don't try to go all the way in a dogmatic sense, but the more side effects I can get out of the program in various places, the better, because it's cleaner and it's easier for me to see what that code does, and it's easier for me to reuse that code in places because I know that as long as whatever I pass it is all that it's going to need, it's very easy for me to make it nice and self-contained. So I do try to make things relatively functional in places where I can. But that's really all I can say about that. I don't feel like there's a need to be overly functional in your programming style, though. You should be as functional as is warranted, and no more.
The language that I write primarily, more than any other language by far, is a functional language. And I don't really feel that strongly about functional programming or object-oriented. I think I've done enough functional programming at this point to where I feel like I'm just more comfortable doing things that way. Oh shit. Are we good now? Thanks for catching that, Devil. Hey, Derpy. Yeah, I forgot to switch my audio over. That was, of course, I messed up. Another technical thing goes wrong because everything has to be just the way that it needs to be to not be messed up. It's good now. That's good. Anyway, like I was saying, functional programming just tends to be what I'm comfortable with. I've done so little object-oriented stuff in comparison now. But I don't really feel like, just like he's saying here, that being dogmatic about it is particularly constructive if it's easier to do something, where you pass a pointer around or pass some data around that you modify, and then you keep doing stuff with that data down the pipe instead of returning something totally new. It doesn't, as long as you understand what the hell you're doing, but maybe I've never done anything interesting or impressive enough to where it's mattered all that much.
Okay. How would you do compression programming with big teams? Will the game be random but always with the same seeds so that everyone gets the same world? Also, will the dungeons change when you revisit them? All right, so there's a lot of questions here. First of all, compression programming with big teams, I kind of answered that already. If you want to take a look at on Molly Rocket / Casey, I actually talk about that. I don't remember exactly where it is because it was at the end of one of these, working on the witness ones where I was talking about that sort of stuff. Let's see, I think it was in this one. Okay, so if you go here, if you go to stream_0020.html, you will notice that I talk about that in here. Like second after last week's article, multiple people strangely suggest that for some reason compression programming would only work with small numbers of people, perhaps 1 or 2, but it's somehow not possible to do when working on teams. And so I kind of explain here why I don't really necessarily even understand why there's a difference between how it works on teams or not. So hopefully that can sort of answer that question a little bit. My feeling is that basically, you just have whoever is working on a particular piece of code at the time is doing compression-oriented programming. As they sort of get the design together, when they are happy, like that exploration process that I was talking about, when you're sort of happy and feel like you've gotten somewhere, you take the interface on the outside of it and you export that to your team. And you say, here, now you can call these things. I've gotten to a place I'm pretty comfortable with, right? And that's really all there is. It's really not that hard, and it doesn't really change anything, whether it's a big team or a small team in my experience. Do you think writing structs and associated functions for things like vector2 and color would be good to cut down on boilerplate code and or show better intent in the code? Yeah, well, so we will be doing those. Again, it's premature to do right now, because if you imagine somebody coming at the stream who doesn't know what a vector or a color struct is, and I just start writing those, they're like, why did you need that, right? And so what we're doing first is we're writing everything in the exploratory way, just writing it first, and then looking to see what patterns emerge, and those will guide us in how we make our utility classes. And I really want to emphasize that that is almost always the right way to do it. It's almost always best to write the code explicit first with no fanciness, and then look at what emerges and pull that outwards. That's the compression-oriented programming model, and that's the model that works. Now, some of us have been around the block so many times that we just know what we would want in a color struct, for example, and that's fine. So if you have written it so many times that you just know exactly what that's going to be, you probably just already have an H file anyway, and you just grab it and use it, right? But I want to show the process where when you're not quite sure yet what a color struct should have in it, or where you're not quite sure yet what a vector2 should do, those sorts of things. I want to show how we arrive at them. So we will never be prematurely making a struct. We will always be building our utilities from the ground up so that you can see how I do it, and how I decide what to do and where to put what and at what times.
I wish it worked out to where I could do what he's describing more often, but more often than not, I'm like, oh, here's something I've never had to do before. How do I even begin? And if it's something, crazy web related, it's like, I guess I'll just look up examples, and then you start teasing apart the examples, and hopefully you distill it down into, okay, this is the piece of information I needed to actually go and build the thing. But you have to strip away all of the stuff that the original author might have tossed on top of it to get to something that you just want to use for exactly the purpose that you need to use it for. It's unfortunate. That's how it goes so much of the time.
Are you going to use linear texture layout or something fancy like a swizzled tile layout, nested tiles for writing, then unswizzle on the right to the screen? Let's wait until we get to the render to talk about stuff like that. If C didn't exist, what language would you use? I probably would be an assembly programmer. I'd probably have my own tool set for making assembly code, probably. And honestly, I'd probably be a better programmer. If C didn't exist by now, either I never would have figured out that I like low-level programming and would have just been some crazy, Python programmer or who knows what, or I would have found the right way to do things and made my own sort of stuff on top of ASM.
Welcome to my life. Crazy Python programmer. I'm not even a Python programmer. That's the language I use the most at my day job, but that isn't the language that I use the most, because so much of my day job isn't even necessarily programming. A lot of it is like dealing with some UI that makes me sick to look at, and so I do have to do the crazy Python stuff, and I wish I didn't. I wish I didn't.
I probably should do that these days, to be honest with you. I've thought about it a couple times, because I feel like my assembly language knowledge is kind of weak, because I've always had C, and because I kind of came at a time when programming the whole thing as an assembly language just simply wasn't done anymore. So Yes, at Handmade Hero also works now for questions. At Handmade Hero, at Casey Muratori, and Q: will all work. We have a crazy filter. Where can we find out additional information about engine architectures? I have no idea. Again, since I don't spend a lot of time reading introductory material these days because I'm so old and crusty, I don't have a good feel for what's available. When I was little and learning this stuff, there were no books on engine architecture. There were no books on games, pretty much. I think like the first books on game architecture that I know of that came out were like really, really awful and came out in like the 90s or something when I was already 16, 15, 16, something like that. There were good books on like graphics programming, like Bruce Artwick's like microcomputer graphics displays or whatever that book was. There were some books like that, but there weren't game engine architecture books. So I don't know. I've never even read a game architecture book. I assume that they exist now, but I don't know if they're any good.
I did read a good chunk of game programming patterns, I think it's called. I can't even remember the name of the author, but it's been around for a long time, and it's been through a bunch of different versions. Yeah, I did call him old last stream. Well, this was like 9-10 years ago when he did this, so he's 10 years older now than he was then. So imagine he might describe himself as ancient at this point. But yeah, I got into that game programming patterns book, and at that point, I mean, this was like a year ago actually when I started reading that book, and it was pretty abstract and very high level, describing like if you came across this scenario, then you might, try this approach. And I could kind of intuit like, yeah, what you're describing seems better than the alternative for me, which is I have no idea what I'd do in this situation because I'm that unfamiliar with games programming. I know a decent bit more now than I did, 9-10 months ago, but I've still got such a long way to go, and to build an intuition for some of these things, it just takes time and experience. And like I can do that for the web. Like if you tell me you need to go build this web related feature, I can be like, okay, there's a really good chance I'll know how to just like start doing that. Or even like if it was a simple enough game feature, I might start looking into, okay, what are some different approaches to doing this? Which do I like? Which don't I like? Eventually I'll come across something that I'm comfortable enough, but I'm going to be way more comfortable with the web stuff because I can you just have a natural sense for the nuance of like, no, this could cause problems in this way and that way. And this, feels better, more flexible. Yeah, it takes time to build that intuition.
Do you envision the game world to be generated as you go and stored in memory on disk to save the state? Oh, I forgot to answer one of the questions from before. Let me remind that. Someone said, will the game be random but always with the same seed so that everyone gets the same world? And will the dungeons change when you revisit them? Who knows? I think those are decisions we can make a little later on. What I would probably like to do is make it so that maybe that you can export like a seed. So you can say, here's the game state. If someone else wants to play my game state, I can send it to them an email or whatever, and they can load it. Something like that might be nice. Dungeons won't change when you revisit them unless they are supposed to. Like, I would like the world to feel consistent, so they probably won't randomly change. Yeah, there's some stuff I want to do with the game design that makes it so that it's not like if you're thinking of like Binding of Isaac where there's like a seed number that gets printed. That won't work at all, because there's some things that I want to do that make that not actually be enough information to regenerate the world. So now back to Johan Overstedt's question. Do you envision the game world to be generated as you go and stored in memory on disk to save the state? I believe it will be generated perhaps in a background process if we can't get it generating fast enough to generate just sort of in an instant, because I don't want to have to wait for a generating screen. I don't want one of those screens like, when like Don't Starve, you're sitting there and it's like you gotta wait for it to generate your world or whatever. I don't want that. So we probably will have to move it to a separate thread, but it will basically all be generated at startup. But I just might try to overlap that with you walking through the first screen or two so that you don't have to stare at a loading screen while the world gets generated. But
I love how like every opportunity he has, he just piles on loading screens as these terrible things. And yeah, generally I think it's probably fair to criticize them, but sometimes a good loading screen positioned well can get you hyped. Like I remember sometimes it can just drag on too long, but I remember getting hyped watching those old Halo and Halo 2 loading screens on like Xbox, where like you'd see the ring, you'd be like following the ring from the outside, and you'd be like, oh my god, we're going to the ring, we're going to Halo. Yeah, I don't know. It's a little bit contextual, but it just seems across the board unilaterally, he's like, loading screens can kiss my ass.
We probably won't have to save it to disk because it probably should never be large enough to have to save to disk. I mean, if you think about it, modern computers have so much.
You don't want to see your crusty ass reflected back off the black screen. Yeah, I mean, the point is that the screen shouldn't be completely black. You shouldn't be just looking at a bar as it fills. Like if you're gonna have to load something, play something to hype up the players to get ready, because they're gonna jump in and they're gonna be the chief and they're gonna start killing some aliens, but you gotta load up. You gotta get some ammo going. You gotta prep before you can just jump in and do that.
Memory on them. That basically almost all of our memory footprint is probably going to be taken up by like bitmap graphics and sounds and stuff, right? So we're going to have plenty of room to probably just store the thing. So we won't need on disk for the game build, I don't think. What was the variable thing John Blow was referring to on yesterday's Q&A? So you'd have to ask John exactly, but basically he was kind of making fun of the entire process a little bit. I mean, John is very supportive of Handmade Hero, and he really likes the project, from what I can tell. So he was not being disparaging of the project at all, but I think he was just enjoying like asking a stupid question, basically, because he thought that was fun, and I thought it was fun too. So way back on the very first stream of Handmade Hero, he asked some question that was like, will you be showing how to program the variable or something like this, right? And
inside jokes between old dudes who've been programming for 40 years. Chelsea said Animal Crossing takes forever and it's almost completely black as well. See, one of the ideas I've been playing with for a game is like an Animal Crossing GTA crossover. You know, obviously much more limited in scope than Grand Theft Auto 6, of course. The game of the century when it comes out next year or whenever it comes out, whenever it's supposed to come out. And I'll make sure that there's no just purely black loading screens. I think that's probably pretty inexcusable. I think it's totally fair to criticize that all day.
I answered it, of course, and since then he's been asking that question often, and I try to answer it differently every time. But yeah, if you really want to know exactly why he decided to ask that question the first time, you'll have to ask him. But I think he was just trying to like ask a stupid question, and that was the stupid question that he happened to think of first. I don't know if it actually, he could have maybe said the function as well or something, right? But
weren't loading screen games patented by another game developer? That doesn't seem like it should be patentable. Seriously, Bandai Namco did. The patent was revoked, so. Wow, that just seems really strange considering like loading screens that are dynamic have been around forever. I don't know. I feel like I'm missing some information here. Like, is this a new thing? Did this just happen within the last couple of years? That makes no sense to me.
Let's see. Are you going to use fixed point? No, probably not, because fixed point's just slower for everything. And so, I mean, so in one sense, you might say there are some things that I might do that look like fixed point. So I guess maybe I won't say no, but basically no. That came out weird. We will do one thing that looks a little bit like fixed point. If I remember when we do it, I'll mention that this is what I was referring to when we get there. But no, for the most part, we'll use floats because floats compute way faster. How old were you in the picture on Molly Rocket? So you're talking about this picture? I was 2010, I think. So I was 30. I was 4 years younger than I am now. So I was 34. This was me when I was 34.
That's what happens when you get to that age. You got to think very carefully. How old am I again? I actually can't remember off the top of my head.
How is it better than just pixels? That's an excellent question. And I can't answer it in a short period of time, so I would ask if you could keep that in your head, if you can remember, and I will have essentially an entire stream explaining why that is correct, sorry, why subpixel is better than pixel when we get to when we start working on the renderer proper, and we're not just using debug rendering. Basically, the reason is because it makes motion look much more continuous. I don't know if you've ever seen like the difference between something that looks like a perfectly smooth, beautiful scrolling of the background, and it like slows to a stop, and it's just beautiful and clean. And then there's these other ones where they kind of jerk to a stop, like as they get slower, you can see it sort of do this thing. That's because one of them was subpixel and one of them was pixel. So we want the subpixel kind, so it's perfectly smooth, even when it's moving very slowly. Will I be
Google says Namco held a patent on loading screen minigames from 1995 until it expired in 2015. The patent covered the use of auxiliary game program code that was loaded before the main program code. This allowed Namco to prevent other companies from using similar... So you're talking about mini games in a loading screen. And that I can, that seems a lot more rare than just like, I'm not talking about like a mini game in your loading screen. I'm talking about just like there's some kind of animation or maybe like a pre-rendered thing that plays. That's a little bit different, but to that point, it is good that, they lost that patent because that's just ridiculous. A game within a game is basically what that is, and it's not... I mean, yeah, I don't see it. So yeah, good on the legal system, I guess, for slapping them down on that one.
Growing a final stretch beard. My wife does not like beards, so seems unlikely. Okay, so are you going to use linear texture layout or something fancy like a swizzle tile layout, nested tiles for writing, then unswizzle on the right to the screen? So
I see.
basically what I would say about that is you're going to have to wait and see how we architect the renderer. It depends what you mean by swizzled. We will probably be doing some things that are not linear layout.
I get it now. I see now. Loading screen games as opposed to just like dynamic loading screens. Yeah, that's a bit of a different. It's a little bit more unique, a little more edge case. Stardew Valley loading screen. You can click on the title for little surprises. I do not remember that, but then again, I have not played as much Stardew as you. Hey, Dode.
But they may not be swizzled in the same way that like a GPU swizzles them, if that's what you're asking. But that will be largely driven on what we find out when we start to do performance tuning. So I'm not even in a position necessarily to say exactly what it will look like. In the sound code, we were trying to decrease lag, but if we just output sound at the start of the frame that is 1 or 2 frames behind the input, would the player really notice a lag of 1 or 2 frames? Probably not for our game, no. I just want to work on a relatively complex sound loop that would be something you would do if you were trying to drive the lag down, because it's just an interesting thing to do on the stream. And some people out there may want to learn how to do that because they may want to make like rhythm games and stuff where it's important what that lag is. So I kind of wanted us to go in that direction so that when we try to do the shipping version of the Win32 sound layer, we can actually spend a week or two, however long it takes, actually getting that sound code proper and actually getting the lag down to be as low as we possibly can. So I'm interested in that. I like that personally also. I like the idea of exploring that. So while we haven't gotten there yet, I think it's better to go that direction and see what's going on rather than just doing the obvious thing of just writing with a ton of lag and not caring.
I feel the same way, Devil. Performance is something that I'm interested in because I've just always liked making things go faster and perform better because there's something just very satisfying about that. It's a very empirical improvement in the way that the thing does the work that it needs to do. So performance and just like doing stuff with graphics is a lot of fun for me.
How different would this initial rendering code be if this were vector-based? Well, I mean, I guess I'm not sure what you mean by initial rendering code. Since all we're trying to do now is put debug rectangles on a screen so we can start to get the game up and running and see what we want from our renderer in terms of like services and architecture and stuff, the initial rendering code probably doesn't matter at all, whether vector or whatever. If you're talking about what the actual eventual rendering code will look like, then obviously vector-based rendering is very different from blit-based rendering, so it would look very, very, very different. Let's see. Todd Punk says, you cut me deep. What did I do? I don't even think I didn't even see, I wasn't even answering a question from you. How did I cut someone deep? That's no good. I didn't mean to, Todd Punk. Let's see. Could you explain a little more about the drawback advantages of OOP? I don't mean OOP as in the dogmatic C++ way. I just mean using OOP abstractions when useful. I don't think there's anything wrong with using OOP abstractions when they are useful. The thing more there is, A, I might disagree with people about when I think they're actually useful, and that's an argument we could have on any specific thing, but it's not really a general argument. The general argument that I have with OOP is actually about OOP itself, literally, not about objects, and I've talked about this a little in the past. Basically, I don't have a problem with the concept of an object, really, because that's very nebulous, and we could define it to mean all sorts of things, and they're not all bad. What I have a problem with is literally OOP, object-oriented programming, because that, by definition, by its very name, means orienting the way that you program around objects. And that, to me, is a very bad methodology. And the reason is because objects are not relevant to how your code works. Objects, like the way that your data is actually laid out, is usually more about performance than it is about the structure of your code. Algorithms are what determine the structure of your code. So if anything, you want to be algorithmically oriented, or you want AOP, if you will. And I don't say algorithm-oriented programming because it's a little nebulous what that would mean. I say compression-oriented programming because I like to think about it in terms of you have code that you wrote explicitly, and then you kind of like compress it down into something by pulling out parts that can be, that can be reused, and so on, much like a dictionary encoder would do. And so I think it's very important to not think about code from the object perspective. And it's less about the code that you end up with, and more about the process of getting there. Because I think going into code with an object-oriented mindset leads to bad code, whereas going in with compression-oriented mindset leads to good code. And it's not about whether there are objects in the system when it's done. It's about how you arrived at them that determines the quality of the end product, in my opinion.
That just basically is an extension of what he was going over earlier, which is like, not being dogmatic about functional. If you like doing things functionally, then great. But if you are always looking through the lens of like, it has to be this way, you're ultimately going to be handicapping yourself in some way. It's true, I did optimize the shit out of my startup. I spent a whole summer last year basically just trying to optimize one query, one database query, and some of the stuff that would fall out of that query, like different data points, and just trying to make it much faster than it was when I originally built it. And that particular query, it's like it's like the core component. It's like the most important query of the entire product on the engineering side. Nothing matters more than that query as far as the whole product from end to end is concerned. So it needs to be wicked fast, and it needs to be very robust and very immune to failures, like when it gets bad data. Or at least there's no input to it that should prevent somebody else, that should break things such that anybody else can't hit the query immediately after with good data. And that's just generally what you want any endpoint, any API endpoint to be able to do, right? But I've spent so much time making that API and the database querying underneath it as just incredible as I can possibly make it. But it's an ongoing thing. It's always an ongoing thing, trying to make it better all the time.
I'm having a really hard time understanding parts of the sound code from earlier in the stream. Are we scrapping that, and can I wait until we rewrite it to get an explanation of how latency works with sound buffers? Yeah, I mean, basically, if there's anything in the platform layer right now that's too confusing or you don't like it or whatever, I wouldn't worry too much about it, because we're not going to scrap anything per se, but we're going to do a pass on it where we're actually trying to make a shipping quality platform layer, where we'll go through everything in excruciating detail. And so, you really don't have to care too much about it if you don't want to. It's really not a big deal at this point. It's just as long as you're comfortable enough with it to like accept that it's playing some sound or something. That's really all you need to be worried about. So we'll have plenty of time to really drill down on that stuff later. Did I work on Neverwinter Nights 2? What an odd question. So I definitely did not work on Neverwinter Nights 2, but I don't know, and this list is not all inclusive. So I guess I'm not sure. So they did use my code. So they licensed my character animation system for Neverwinter Nights 2, but I didn't work on the game engine or anything, right? They just used my character animation. This is the character animation system I wrote, and this is like a partial list of the people who the games that it's in or whatever, and they're on there. So I guess they used it for something. I don't know. I don't remember what, because I don't even know if I ever got any support emails from them. I don't recall. In the rectangle drawing code, can the compiler optimize the code on the basis that the pixel buffer does not alias the loop counters, or does the compiler not know this? The pixel buffer alias the loop counters. Mr. Casey does not understand the question. So, just so we're clear, aliasing only happens if the compiler thinks that you could have taken a pointer to something that you are writing to with a different pointer. And since these are defined entirely within the structure, everything from basically there are no mutable variables from here that the compiler doesn't know about, as far as I know. So I don't think there should be any aliasing whatsoever, because there's only one pointer, which is the pixel pointer that it's writing to, and it sees that min y, max x, min x, max x. It knows their lifetime; they were here, and no one could possibly have gotten a pointer to them because it never gets passed to anything. So I'm pretty sure the compiler would never have any reason to think that anything was aliasing in here. But I'm not a compiler vendor, so. If you really want to know, compile in release mode and see what the compiler generates. That's the only answer pretty much any time to a question like that, is see what the compiler generates. Because until you actually look what the compiler generates, even if you're pretty sure, you could be wrong, because there could be a bug in the compiler for all you know, right? Like, even if the compiler should have known, it may not. So, keep that in mind. Will we be doing anti-aliasing in the renderer? Yes. If you start going bald, will you cut off all your hair or comb over? I don't know. That's a good question. I am kind of, you can see I have a kind of a balding spot in the back. I don't know. I haven't really gotten too bald yet, so I'm not sure which would be more appropriate. I'd have to try it and see.
I personally would probably just shave it all off. I don't think I could handle having just like wispiness, but I'm not too worried about that at this stage of my life. I've got a lot of life left, hopefully, so hopefully I'm good.
Is it possible to explain the subpixel smoothness thing you mentioned with an example video from other games? Yes, but I don't probably know exactly which ones would be the right ones at the moment. I'd have to go find some videos. Is this game going to be similar to RuneScape? I have never played RuneScape. What do you suggest to develop games on mobile environment? Well, that's kind of an open-ended question, so maybe pre-stream? Ask during a pre-stream for that? Let's see. Can we use DirectX 11 while we work on rendering the Windows layer? I don't know what we'll use. We probably wouldn't use DirectX 11. If we were going to use DirectX, we'd use 12. Because otherwise, if we're going to use 11, we'd just use OpenGL. Will you add Pokemons to your game? No, we don't have a license. Disparaging Python programmer. Oh, Todd. I was not disparaging Python programmers. I'm sorry. When I said crazy Python programmer, I did not mean that the Python programmers were crazy for programming in Python. I just meant that Python is kind of crazy. So when you're programming in it, it does kind of, you're doing kind of wild and crazy stuff, right? It's like, it's wild in there. So yeah, I don't think people are crazy for programming in Python. I think Python's a totally reasonable language from what I've seen. It's a little too, it doesn't quite give you the CPU control that I want in a language, so it's not the kind of language I tend to gravitate towards, but, I mean, I don't have a problem with Python. I'm sorry if I gave that impression. That's not true. I don't have a problem with Python.
I was devastated. I'm a Python programmer. I was devastated when he said that.
Or Python programmers, for that matter. Will this game feature dinosaurs? Who knows? We'll have to see when we get there. How can I get a job working for someone reasonable like you? Pre-stream question. Please ask those in the pre-stream. Come to a stream early and ask those questions. I'm happy to answer them. I gotta go soon, so I gotta blast through the rest of these. Will they have sharks with lasers on their heads? Well, it certainly seems compelling. I don't know what to see. Rideable animals? I don't know about that. How often do technical limitations impact game design in your experience? Well, it depends on the game and the technologies, obviously. Sometimes quite a bit. Like you can imagine games that were based around physics, sometimes the technical limitations can really have a big impact there because physics is sort of a difficult to manage technology that oftentimes isn't very stable and so on. So there's definitely times that happens. Also, rendering limitations can definitely affect game design. So games where you're trying to do like millions of guys fighting in a giant, battle kind of situation, you can imagine things like this. So there are times when it matters, but on the whole, I think most of the time good game designers can work within the limitations pretty well, and bad game designers can't, I suppose. But so I don't know. I'm not a game designer, so maybe you should ask John Blow that question, I guess is what I would say, because he's the kind of guy who would really have a very smart game design-oriented answer for that, whereas I'm just a programmer, and I don't want to speak for designers on that.
When is Jonathan Blow going to do Blow-Made Hero, where he does this series format, but he designs a game from scratch instead of programming one from scratch? That's what we need after Casey eventually comes back around and finishes this series. That's what I want to see.
Use member functions? Probably not, no. Certainly if we did use them, they'd be in a very limited case for doing a very specific type of thing, which we'd see later, but probably not much member functions, no. Let's see. Will the Owl of Shame replace Navi and Handmade Hero? I don't know. I'd have to license the Owl of Shame from the company. I guess we could do something that's similar to the Owl of Shame, but we can't literally put him in the game because he's, he's somebody's copyrighted work. All right. Let's see. I think I'm going to have to end it there. Can you show me an example of how you'll be using the game memory block? Yes, so Guitar Freak, we will be using the game memory block very soon. Just hold your horses a little bit. Don't really hold your horses. Just rein them in slightly because they will be off and running within 2 days, let's say. So keep the horses like ready out of the barn, but hold them a little bit. And then, by the end of this week for sure, we'll be using that memory block. Let's see here. Didn't mean to hold that down. Maybe I'm missing something, but what if both min-x and max-x are lower than 0? So the idea is if min-x is less than 0, it'll get moved to 0, right? If max-x is also less than 0, then when we come in here and it does x equals 0, x is less than some number less than 0, it'll never enter the loop. So it'll never do a write. That's how that works, if that makes sense. So if you look here, so if you want to see that in action, we should probably test that case anyway, just in case there's something broken in it. But there it is, and you can see that it doesn't crash. And the reason for that was just what I said. It's like basically that you're protected because you only have to clip one of the values, and then it will automatically, this less than is essentially the clip for the other value, if that makes sense. If I was somehow able to acquire a license for Pokemon to use, would you use it in this game? No, I'm sorry. I would love to do something like that, but the reason that I can't do that is because I want this entire game to be released into the public domain someday. And so everything in it has to be owned by me 100% so that it can all be released. So yeah, sorry. Otherwise, I would love to do that. Will the game have a moral social message? Do you have someone writing for you? No, it will not have a moral social message. This is strictly about game development, not about game design or narrative. And so we are strictly basing the game design on stuff that we want to program and that will be interesting to program. So yeah. All right, I really have to go. So thank you very much, everyone, for joining me on this edition of Handmade Hero. It has been.
All right, I think that is a good place to cap it for day 27's Q&A. Let's see here. I can kind of wrap up this code over here, and I don't think we really need to see Casey while I get this done. I can bring up day 28, although yeah, I think I might have time to at least start it. I was really hoping to map the streams to like I'm gonna do one day of the series at a time, but I think that's just too optimistic because inevitably I'm gonna get stuck on stuff, and it's just, you know, it's gonna be, I'd be streaming for like 4 hours in one day, inevitably once I hit a real challenging day where there's a lot of fancy code being thrown around. Blow-Made Hero sounds like a gay porn. Well, I mean, he can make the series about whatever he wants to make it about, but I don't think he's got enough on his plate. As far as I can tell, he's trying to write a whole new, like, indie game, but the scope is probably bigger than any other game he's made. He's the same guy that made Braid and The Witness, and he's trying to write that new game in a totally new programming language, and that is, you know, more power to him, but he's been doing it for literally almost 10 years at this point, and I'm sure he's tired of taking on new projects. But if he made Blow-Made Hero, I would probably watch it. So when I was going over this code earlier, I think I can actually close that and then move my OBS stuff over here. When I was looking at this code after I wrapped it up yesterday, I realized that I still needed this check, this guard, so that I'm not writing over the end of the buffer or trying to write outside of the bounds, because on that last pass, when you're writing the last row of pixels there, without this guard, if you're going to the end of the frame buffer and you try and do this, it will crash like so. So I had to re-add that, and I'm not super happy about it. You know, it's just not, it's not great. I don't like having to have this one guard for like the last iteration of the loop. Well, not the last iteration of the loop, but anytime the dimensions of the rectangle being passed into the draw call are going outside of the dimensions of the buffer. For every single iteration of the loop, we have to have that guard, and I'm just not thrilled about it. I would like to be able to just index it properly, and it's just hard to transform my thinking in that direction, just because I'm used to looking at the way Casey does it, and he's just doing pointer arithmetic, and he's moving, you know, through the frame buffer in accordance with just, you know, adding these dimensions to the memory as he's, you know, iterating through these nested loops here. So Devil, I think, was mentioning yesterday that, you know, here aren't we just accessing the xth pixel, and therefore we could do this and then we don't have to increment. But the problem is we're advancing this slice. It's just different because we're working with slices. I'm not working with pointers, and so the way that I'm indexing into the pixels is not quite, it looks right there, but it's not quite right. And you can tell if we go back to that draw call and we make our rectangle real big, it'll actually wrap all the way around because of the way we're indexing the pixels there. And that's not what we want, right? Like, we want it to basically show as though the rectangle, the rectangle should write out to the ends, to the end of the dimensions of the buffer, and it shouldn't, the bounds of the rectangle that are outside of the buffer should not be wrapping around to the other side. So I just have to think about the way I'm doing that very carefully. I was playing around with it before I started the stream, so I was a few minutes late, and you know, I couldn't figure out how to make the math make sense in my head, and I didn't want to delay the stream anymore, so I'm just gonna leave it like it was. And I know that I'm pretty sure that we're gonna make some more changes to this proc here in the next day of the series, so I'm not going to mess around with it anymore, because I'm pretty sure we're gonna break this apart, and instead of transmuting the row of pixels into U32 slice, we're just going to write in the RGBA in each individual slot where it belongs. So all of this is going to change here anyways, but depending on how it looks after all that is said and done, I'm going to mess around with this a little bit more and figure out how to do this properly, because I just don't like having this here. This is lame. We can do better. So I'm going to go ahead and make sure I didn't do any oopsies here. I want to make sure I didn't fat finger anything in my diff before I go off and commit this to the repo forever. It's just an OCD thing that I've been doing for a long time now. I like to look at the diff before I go ahead and commit it. So this was day 27, and I should not have swapped my tab here before. What was this? Exploration based architecture. All right. Look real quick for typos, and we're good. So I'm gonna go ahead and push that up to my private little repository. And I can't. What happened? Things work that you do not have locally. Oh, I see. It's because I added a script on the Darwin side. That's kind of lame. I don't like having that random merge in there, but it's just for me anyway. Who cares? Okay. Moving on. We're just going to jump right into the next day, I think, because I want to write some more code. If I can figure out what am I doing. I'm over here. Okay, so I got to move my OBS back over here. Can't even imagine working on one thing for 10 years. Well, I'm starting to imagine that I'll have to. I'll be in that same place like 4 years from now. I don't know. You just, there's a sense of like once you're in too deep, you can't really walk it back. And in his case, that's very true because I mean, his whole business is he runs an indie game studio, right? And if you're 10 years invested into a project and you've been paying people salaries for all this time to help build your game, and he's had developers come and go the whole time he's been working on that project, eventually, you know, he has to make that money back, or at least attempt to make some portion of it back when he goes to ultimately release it. Whereas I've just put in a lot of sweat equity. I haven't paid anybody. I guess you could argue that I've been paying myself out of my own wallet, but like eventually all that stuff, you know, is left up to taxes and all these things. But really it's just been me doing it in my spare time when I can manage outside of all the other things. So you don't really get into something like that intending to work on it for 10 years. That's just what happens because you keep on pursuing the thing, right? And if you had known ahead of time, if you could look into the future and be like, where does this path take me? And you saw, oh, it's 10 years before this thing works out. You might be like, I don't know about that. But then you know that it works out eventually, right? So like that you have to have faith in this thing that you're putting all this effort and time and attention to. And so, yeah, it's kind of, in that sense, it's more about the journey. Because if you just knew what the end result was, oh, if I put 10 years into this thing, I'll get this outcome. That's not as exciting, right? It's kind of about you don't know if it's going to work out. So the stakes are higher. And you got all this time invested into something that's really important to you. I think it's important to have something like that. I mean, if you're somebody who wants to get... have a life partner, just a totally different thing. Like we're not talking about a work project or a passion project at this point. We're talking about something that you want to commit. You're talking about a person that you want to commit the rest of your life to, you know, like that's a very different thing, I know, but you know, it's like, can you imagine you might have to work 50, 60 years on just one thing, which is that relationship, right? I know it's a very different thing and not everybody's even in that, you know, place where that's something they want out of life, but just a different example of that sort of thing where there's all sorts of things where you don't really think about the time scale of a thing as you're getting initially invested into it, you know. like when I started writing code for the first time, it wasn't something that I was like, I'll be doing this for the next rest of my life. It was like I was in the middle of a class and at college. It was like an entry level. It wasn't like the here's what a computer is and here's what a keyboard is type of class, but it was basically still pretty introductory as far as like how to define classes, using OOP, that sort of thing. Anyway, real big tangent. Let's go ahead and jump into day 28, where it looks like we're actually going to draw a tile map, which is fun. If I can properly set up the stream here, I want to make sure that these are right around the same volume I've had them. I think that volume's been working out just fine. And we'll see. I don't think there's going to be nearly as much whiteboarding this time. Where is my source here? My Casey Cam, I called it. Triple A, welcome. And somebody subbed? Is that what happened? Over on the Twitch. Hey, Triple A, thank you for the resubscription. 30 months at tier 1. What? That's insane. Thank you so much. Welcome back to the stream. Okay, let me figure out. I think I'm actually good. I don't think there's anything else. I feel like I'm missing something. It always feels like I'm missing something. I'm still not totally comfortable doing this again yet, to where it's like I just feel confident that there isn't something totally screwed up with the way I have things set up. So yeah, let's jump in and see. I guess we can see if he'll whiteboard anything up front. I might as well be in a position to where we can watch him do that. But I think we're just going to jump headfirst into some code this time.
Reset, there we go. Sorry, cycle recording, not gonna cycle the timer. All right, welcome to Handmade Hero here on day 28. We are in the middle of our sort of architecture stuff, our game architecture stuff, where we are starting to think about how we want this game's code to be structured and how we want it to work. Yesterday we wrote a little function so we could draw a rectangle on the screen safely, so that would basically allow us to start doing some debug stuff. I wanted to talk a little bit about how to make the rectangle colored today. We're going to think about like basically colors and how those work just really briefly at the beginning of the stream. Again, we're saving any of the hardcore rendering stuff for when we actually write the renderer, but there's a couple things I have to do just to get stuff up on the screen, so I'm kind of explaining them lightly. And then we're going to start generating tile maps and doing some things with like trying to move characters around, that sort of stuff. So basically what we're trying to do is we're trying to make sort of the initial game code, just a first pass, whatever comes to mind, so we can start to look at how it looks and think about how we might want it to be structured. Because one of the big things that I was trying to emphasize on the previous 2 days when we were basically just talking about architecture and how you should think about it, is you don't want to do a lot of pre-planning, because pre-planning, you usually just don't have the information you need to make those good decisions, and you're just going to make mistakes that will cost you a lot of time. And so usually what's better to do is explore first, learn, and then go back and say, okay, now that I've learned what this code should look like structurally, now I can say definitively this is the architecture and move forward. So that's exactly what we're doing, and we are going to continue with that today. So if you have pre-ordered the game here on handmadehero.org, you should have gotten a link in your email that allows you to download the source code. In that source code is a zip file with each day's source. Basically, open it up, and there's a zip for every day. We're on day 28, so you unzip the day before, day 27. Start with day 27 source, and you'll be exactly where I am right now. With that said, let's get started. We've got a lot to do because we're right here at the beginning of the game. It's a giant open field in front of us, basically. So I am going to go ahead and get everything loaded so we can get started. All right. So if I remember correctly, we were at the point where basically we can size the window however we want, but we don't do anything with the exercise right now. We're only drawing it up into this upper corner. That's basically the entirety of our game. There's some things that I want to do with that as well in the future a little bit, but we'll talk about that later on. So this is our game, and we also have our handy-dandy editor here. So let me go ahead and open up our handmade.cpp, which is here. So at first things first, we should probably clear the screen. Well, you know what? Let's talk about this for a second. I actually do like clearing the screen to purple, because you know what we should probably do? If we clear the screen to this hideous purple, which is not something we're probably going to use in our debug output at all, if I clear the screen to this hideous purple, and then we go ahead and make a little tile map thing that has little squares, and we color the squares in, at least then we'll be able to see anywhere that we are not actually filling, because we'll see this hideous purple show through.
Maybe it's just because I'm so loud deep down, but I have no problems with that purple. I think it's a beautiful, hideous purple.
So maybe it's a good idea to leave the hideous purple in there. I'm not so against the hideous purple, so that's good. All right, so what I wanted to do before we got started today in terms of the color, I had this to do in here that says floating point color tomorrow. What I wanted to do is just talk a little bit about that and get you a little bit more familiar with that so that we can make the colors make a little more sense. Because, you know, right now we're basically doing what amounts to sort of web colors, right? I know you've seen it like pound, AABBCC, that sort of thing, or, you know, AA00FF or something. You've seen this if you've ever done any web programming, that's how web colors work. But basically, right, that is the hexadecimal encoding of the color. And there's a lot of reasons not to like this. It's basically packing the red, the green, and the blue into the bottom 24 bits, and I guess alpha if you've got it, but into the bottom 24 bits of a 32-bit integer, and there's not a lot you can really do with that. It's not an efficient way to work with it, because the most efficient way to do math in the CPU is using the floating point unit, and this is not floating point at all, right? So if you think about a lot of the things that you might want to do with color, like one thing that we might want to do with color is blend two colors together, for example. Another thing we might want to do with color is make it darker or lighter, like blend it towards black, right? These sorts of things. The math for doing that is really easy to do in floating point, but if it's in this crazy packed format, it would be a lot more difficult to do, and we'd have to work out all kinds of fiddly bit things to do it. And so usually what you would do is you wouldn't ever do that. You would load it into you know, an SSC register or something like this and up convert it to floating point. Anyway, so basically what I want to do is get you used to working with some floating point colors to begin with, because that is going to be the most efficient way always to think about them. And if we do pack them back into this crazy format for space reasons at certain points in time, like when we want to store them, we may decide that it's more efficient to store them this way, for example, then that's fine, but that should be something that we do explicitly to save space and explicitly for that reason, not as a general way we think about colors. So what I want to do is pass three floating point values here, red, green, and blue for our color. Now, I guess, again, I'll save a lot of this, talk about it more on the rendering side of things, but I guess I'll point out the reason that we do red, green, and blue, obviously, you may wonder why we have that as our basis for colors. Essentially, the reason that red, green, and blue are what's used is because that's the cleanest sort of orthogonal basis you can use for the human visual system. The human visual system is sensitive to red, green, and blue light. It doesn't really have a way of sensing other color wavelengths, because light is basically a continuous wavelength thing. Light, you know, oscillates like light waves, right? Well, you know, what we know about light waves in physics anyway. Light is kind of this mysterious thing that we're always kind of learning more about. But light essentially has a property when it, you know, any given sort of photon, any given piece of light has a property that is its color, and that is its oscillation. Sort of its frequency of oscillation that it has is actually at a specific color. So, you know, you can have light that is actually a certain shade of yellow, right? And it's not a combination of red and green, which is how we think about yellow in programming, or, you know, or artists even think about yellow when they open up GIMP. You know, I mean, we think about it, we go in here, when we actually think about color, I don't even know how to use this little tool, but I assume there's some way for me to get a, I don't know if there's like those little, you know, I'm talking about those little sliders that are around. Let me use ColorPop, because that's got them. So we tend to think about it as like this sort of thing, where we've got like a red, a green, and a blue, and the red and the green and the blue could contribute a certain amount, right? That sort of thing. Or, you know, there's other color spaces, hue, saturation, value, all this sort of stuff. We think about it that way, but really light isn't that way. Light is not a mixture of red, green, and blue necessarily. Light can actually be a specific color if it wants to be. It can be exactly yellow, or some specific yellow, some specific wavelength of yellow. And so it's just that our eyes, because they only have like red, green, and blue receptors that have these kind of filter patterns that we use, because we only see in terms of those, our eyes can't actually tell the difference between a single set of light, you know, single set of photons coming in that all are actually yellow, and oscillating photons that are coming in that are like one's red, one's green, one's red, one's green, one's red, one's green, right? So we just kind of see this like integration of the light that hits our eyes. We can't tell that what we're seeing is a specific wavelength or not. We wouldn't know, is my point. So we've basically built, and again, I'm not a physicist, so take all this explanation with a grain of salt. This is like the explanation for computer programmers, right? It's not the explanation for people who study light. People who study light probably would be like, oh, don't explain it that way, you're totally wrong. But for programming purposes, what's important to understand is we don't need at the moment, or have not found any need to in practice, actually represent light in any better way than that, because since the human visual system seems to only be able to really distinguish red, green, blue, and it sees other colors by looking at the combinations of the red and green receptor responses, or green and blue, or red, green, and blue responses, we don't really have to worry too much about the fact that we don't actually capture, you know, our monitors don't actually ever produce yellow light. They just produce red and green light very close together, and when they hit our eye goes, oh, it was yellow, right? Now, it's worth noting that if we're simulating light inside the computer, all of this becomes not true. If you are doing a photorealistic renderer, for example, and I'm not talking about photorealistic rendering like the kind that you do in real-time graphics. I'm talking about like offline, like the kind you might do for an architectural viz, like Maxwell render or something like that. One of those renderers that takes a long time to generate an image, but it's supposed to be very accurate as to what light would do. At that point, it's not true anymore. At that point, you do have to worry about the wavelength of light, the actual wavelength that the light should have been, because there are optical phenomena that depend on those wavelengths, like prisms and stuff that split light into pieces. I mean, I don't really know what they all are, to be honest with you, but when you have materials that you want to simulate, certain materials actually respond differently in terms of the light that they reflect based on the wavelength of the light that's coming in. And so if all you know is that you have a certain amount of red and a certain amount of green coming in, and you don't know whether that actually came from a yellow or came from, you know, a separate red and a green that were coming in together, you won't be able to compute the actual color that got reflected off of the surface properly, because you won't know which they are. So it's not true that in computers graphics we can always not care about this, because it depends on the level of realism you're trying to achieve and the circumstances. But it is true that when we finally get to the output layer of things, when we're just trying to draw an image on the screen after it's already been computed, at that point it is true that we have never really found a reason why we would have to produce other colors. Red, green, and blue is sufficient, and as long as we can control the amounts of them, the eye can't really tell the difference between this as being yellow, actual yellow, and this as being a combination of red and green pixels that get lit up, right? All right. So since we know that that's true,
I can't even tell you how trippy the whole thing with colors and light and how all that works is. The thing that I always go back to is that, what is it called? The mantis shrimp, and how it can actually see colors that we can't. Like there are colors, there's a part of the color spectrum that exists that our eyes just can't, the physics don't exist within the way our eyeballs work to be able to see those colors that the mantis shrimp can. And then the fact that it punches at like Mach 1 or whatever the hell, so it can like bust out of a fish tank if it wants, and unless you have like bulletproof glass or whatever. Will, gotta love the 2x tutorial speed. Well, not quite 2 times, it's 1.5 times, but man, time is of the essence. I gotta get through as much of this as I can, as fast as I can. So we're on hyper speed, Casey here. I can't tell you how just I was looking at your comment and I was like, it's really him. I can't believe it's been, I can't remember the last time we would have hung out or talked, but it's probably been like 13 years, 12 years. I'm trying to remember how old I was. But it's good to hear from you, man. Looking forward to catching up with you sometime soon. All right, so I think we're going to jump back into some code here. Certain eye surgeries allow humans to see ultraviolet. In World War II, people who had this surgery would send each other secret signals using ultraviolet lamps. That's pretty dope. That's pretty sick.
And since we know that our monitor has a particular brightness at maximum that it can output.
I mean, the whole being in war thing, not so sick. But the fact that they could communicate that way, that is pretty cool.
What we can sort of think about is, we can think about saying we just want a range of values between the darkest red, which is like no red being output, and the brightest red, which is the maximum red that the monitor can output. We've got a range between those, and we typically pick 0 as the no red value and 1 as the red value. And 0 is the no green, 1 is the full green. 0 is the blue, 1 is the 0 is no blue, 1 is no blue, as like full blue, right? And the reason that we do that is because it makes our math with them be a lot easier, right? If we set 0 equal to none, right, of something, and 1 equal to full, then the nice part about that is that if we want to get something, if we then want to know sort of any kind of, I'm trying to think of what the easiest way to sort of show how this happens is. Basically, all of your blending operations, everything that you might want to do with numbers is easier when you normalize them to the range 0 to 1, specifically because you can always count on them being sort of in that same scale range, right? What's a good way to show this example? Colors is not the best way to do it, because really I think a lot of times with colors, because they're separated into channels, it's not really going to be quite the same. But I'll kind of show you an example in another space. So let's say I want to know how much of something I have, like sort of a percentage, right? So I want to know, like, I've got I want to represent in floating point some amount of some arbitrary thing, and that thing has a range, like we said before, where there's a none of it and there's an all of it, and then we want to represent everything in between, right? And let's say it could be anything. It's like we've got, we want to say that we've got a pound of almonds, right? 1 pound of almonds or something like this, and we want to represent how much of that we have. So one interesting thing about normalizing things from 0 to 1 is that it can always be multiplied conveniently into whatever the thing actually is. So if I then have basically a percentage, right? If I have a 0 to 1, 0.0 to 1.0 of something. If I ever have a ratio like this, I could trivially multiply whatever the value is into any concept of what the maximum amount is. 1 pound of almonds, 100, and 1 Dalmatians, however many anything I have. I can always take one of these normalized values and multiply it by whatever the thing is and get out how many I would have. So for example, if I have 101 Dalmatians, right? If I have 101 Dalmatians and you told me that I had 0.75 was my ratio number, right? Which equivalent of 75%, right? If I want to know how many Dalmatians 75% of the Dalmatians is, right? I can just multiply directly by that value. I can say times 0.75, and there I know I have 75 and 3/4 Dalmatians, right? Similarly for my pound of almonds, if I know I have 1 pound of almonds, I can do it times the 0.75, and now I have 3/4 of a pound of almonds. If I have something like 735 viewers on Twitch, right? I don't know how many viewers are on Twitch right now, but let's say we've got some viewers on Twitch. That's probably a lot for a morning stream. So maybe not that many, but let's say it was an evening stream, maybe you get that many. And so then we go ahead and we say, how many viewers is 75% of them? Well, it's 551 and a quarter. Unfortunately, one of our viewers gets drawn and quartered apparently, and we only have a quarter of them, but who knows? Or maybe that's a split attention. So basically, what I wanted to kind of impress here is that doing things as a number between 0 and 1 kind of has this fringe benefit of you can always do math, you can always upconvert from a 0 to 1 range into any other range that you want. But the same is not true for if you store the values in their actual space. So let's say we had the 101 Dalmatians, and then I said, well, now we have 75.75 Dalmatians, right? That was the number we had before. And now we want to know how much is that same percentage in Twitch viewers, right? Well, I can't just multiply 75.75 times 735 and get the same percentage of Twitch viewers. First, I would have to do the divide. I'd have to do the divide back out. I'd have to say 75.75 divided by 101 to get me my 75% again. And then I could multiply it by the 735 viewers on Twitch, and then I would get back the actual number. Does that make sense? So percentage, or which is 0 to 1, in representing floating point, is kind of the universal storage for the amount of something that you have. It's a dimension-free way of storing an amount. And so we typically use it for things like this, where we're just saying how much of something do we have, where we don't really want to talk about any actual output units. It's usually just the most convenient space. So you'll see it happening a lot, and so it's a good thing to be comfortable with. So what I want to do is I want to do exactly that. I want to say that we pass in an RG and B. And then what I want to do is reproduce this color value that we used to be making here, right? I want to reproduce this color value by sort of pulling out what the values of the color value should be if we had this 0 to 1, 0 to 1, 0 to 1. Now this is, again, a color value that's made to write into one of these ABGR buffers. Remember we talked about ABGR way back in the screen, right? So we know that our bit pattern, right, is going to be something like AA, RR, GG, BB, right? So what I need to do, and again, this is each one of these is 8 bits. That's 8 bits. 2 nibbles, 8 bits, right? 8 bits, 8 bits, 8 bits, 8 bits makes a 32-bit number. So to produce one of those 8-bit values, right, I know I have a number between 0 and 1, and I know the maximum that an 8-bit value can be is 255, right? So if I wanted to produce an 8-bit integer value from a floating point number that's between 0 and 1, I need to first take that and multiply it out so that I get 255 at maximum and 0 at minimum, right? So that's one way to do it, right? I could say that I'm going to have R, and I'm going to make it be equal to I'm going to multiply by 255, which means that I will get, and then I can truncate that to, change that to an integer value. So one way I could do it is that. But if you think about it, there's a little bit of trickiness involved here. There's a little bit of subtlety involved. And the reason for that is because, well, when we multiply when we do this and multiply by that value, do you remember what I said about the rounding yesterday? When we talk about how the rounding works. Oops, non-black color there. You remember I was talking about the number line, and I was saying, all right, we've got this number line, and it kind of goes on, right? And it's like 0, 1, 2, 3, 4, and so on. And I was saying in C, this int32, when I do the cast from a floating point value down to an integer value, it's going to truncate, right? So what that means is if the color value was like here, right? So let's say I multiply this out, and let's say that the value comes out to be 0.9, which is almost 1. So so this value is something really low, and it multiplies by 255, and the value, so R times 255 becomes 0.9, right? That's just what the result is. It's right like up here, but the truncation is going to move that back down to 0, right? So what we might want to do is do the same rounding thing that we did before, right? Now, you could argue about what is the more accurate thing to do here because it would depend on how you were producing these R values to begin with, what you actually wanted to have happen, but it seems like, a totally reasonable thing to want to round, right? Because we know that we'll never produce anything higher than 255. So, because the R, if it was 1.0, which is the maximum value, we know that we're going to allow, we know that we would never produce anything higher than 255, so we don't have to worry about it wrapping up to 256, because we can never produce 255.5 or higher. So what I might do is say, let's go ahead and do that same rounding operation, because that might give us a little bit of a more accurate conversion, but rather than doing the truncation, right? Does that make sense? So I'm just going to do that for now. Again, when we get to the render, we can talk a little bit more about those values and really think about what the most accurate way is to deal with everything. I'm kind of getting too close to my head there. So what I want to do, is I want to be able to produce one of these for each of my color values, right? I want the R, the G, and the B. I want those all in here, right? And I want, when I have the R, the G, and the B in there, I'm going to multiply them each out to basically get a number between 55 and 0, 0 and 55, and that's going to now be an integer value. And so now all I have to do is do the bit packing again to make sure that they each end up in the right place in my thing. Now we know that R was 24 bits up, right, on the bit pattern. So we know that that is, we know that it's from bit 24 down to 16. So we've got to shift it up 16 so that it starts at bit 16, 17, 18, 19, 20, 21, 22, 23, 24, right? The 8 bits starts there. The green value was right below that, so that's 8 bits up. And the blue value was at the bottom, right, so that's 0 bits up. Now we don't actually have to shift by 0, but sometimes it's kind of nice to show that so you can kind of just see it cleanly where each thing is going to go, right? Kind of just a nice thing to line up. And then if we OR those together using our bitwise OR, right, that will basically combine each set of bits, right? So we've got a set of bits here, the set of bits here, the set of bits here. They'll each going to get converted up. Now, of course, I lost my little cast in there. My cast actually needs to be...
Gotta cast these. He was just about to say that, but I gotta cast these over to ints, and then I can have my color. Of course, we can't just write it out to the pixel. Oh, we gotta make it a U32, not an int, I guess. That makes more sense.
Oops. Oh, I don't need the cast anymore. Duh. The cast actually is taking care of it right here, right? So that's actually totally fine. Now, I didn't want a signed value here. But I think that's actually fine for it to be signed. But you know what? I could actually do this. I could actually make one for signed and one for unsigned for the moment, just to be explicit, because sometimes, you know, later on maybe we care. Who knows? So there we go. Let's see here. And so now we should be able to specify our color values in a way that's a little more sort of. It doesn't have that weird 0 to 255 thing in it. So now instead of that, let's actually pass it red.
I see. So he explicitly casts the result of his round back out to the type that he wants, but because we're using the built-in, well, not the built-in, but the round proc on the math package, we just get a float back. So we have to, whatever we want out of it, we have to manually cast it back to that U32.
Green, blue, that's just a little more confusing.
Okay, and then go down to our draw, and we're gonna say, what was that? He wants red up to 1, green 0, blue 1, and then yeah, that gives us that hideous purple.
Convenient and easier to understand. And let's see, to reproduce this, we have let's see, green, blue. There we go.
And then cyan, right? That's what that is. And looking good. Looking good. Yep. Nice.
Oh, okay. A rectangle. And let me see. There's our rectangle up in the corner, as we expected, and the colors are correct. And so now it's kind of nice to, because I can sort of see as we go. You know, it's much. There we go. Does that work now? Yeah, there I can flip back and forth. So basically, if we go in here now, you can see as I go, if I want it half bright there, I can do that. And what happened? Oh, I didn't recompile. I switched to recompile. If I want half bright there, I can.
I guess I might as well do the same thing that he's doing here. Make it just slightly easier to catch up, or keep up, rather.
Do that, right? I can change it back up to full bright. Oops, change it back up to full bright. Let's say I want to make this more of a yellow color, right? I can do that. If I want to make it pure red, right? And so it's pretty easy to see like how these color values mix together, and they're just between 0 and 1, so you don't have the 255, the weird 255 nonsense anymore going on. So that's it. That's just all I want to do there, right? So already you can kind of see, and I don't know if now is necessarily the right time to do it, but already you can start to see too, there's some structures that are starting to emerge here. Like chances are we're probably not often going to pass a red value by itself. It's probably going to come with a green and a blue, right? And so you can start to see already, game architecture wise, just low level stuff, you can sort of start to see what we're going to probably want to do here, right? We're probably going to want to make a struct that will capture the concept of a color so that we don't have to keep passing our RGs and Bs around. I'm not going to quite do it yet, but you can, because we only have even one function that uses it. But think about that. Just keep that in the back of your mind. These are the sorts of things that you should start to be paying attention to, right? You should start kind of having this inkling in the back of your head. When you see that, you're like, okay, there's these operations that are happening on a color. There's a way that represents them in uint32, and then there's this real 32 version. I'm passing a bunch of things together. There's just a lot of things you can start to see if you're paying attention that may be that way. A rectangle might be another one. You can see that we're doing operations on rectangles here. So there's things that you can start to think about in terms of what might be useful for the low-level architecture stuff that we might want to start doing. They're starting to emerge already, and we haven't even really done anything yet, right? All right. So again, let's make the most stupid basic tile map that we might want to make. Let's just make something extremely simple for a tile map that we can draw on the screen. So what I'm going to do here is really the most basic, simple thing that you could possibly imagine. I'm just going to say, all right, I'm just going to have some 32-bit value, and I'm going to make a tile map of them, and I'm going to say how big do we want our tile map to be across and down, And I don't know. I think I thought about this a bunch, if I remember correctly, earlier on, and I'm not sure what the value was. I'll look it up because I thought about this. I think 16 across was what I thought that the right value was for the number of tiles going this way, and I think it might have been 9 down. I think it was 16 by 9, like roughly the same as an HD aspect display ratio. 16 tiles across by 9 up and down. And I don't know, that may be a little too big.
I have not tried to make a nested slice with Odin before, and I think he's just going to make it one-dimensional anyway, so I might just leave it like that and not bother trying to make it nested, because that just seems like, not the thing that we want to do. Did he stop streaming and doing Handmade Hero? He is on a hiatus, so if you try and go to the website, which I will do right now, if I can figure out where my browser is. I was just on his website earlier trying to find that blog that he was showing earlier on, and he's got some more recent stuff, but I don't know how to find that old one where he talks about, well, I guess, yeah, he has links to all of it in here. I think. It's all external, I suppose. So yeah, if you try to go to Handmade Hero, it just redirects you to his company's website, and it says, Handmade Hero is currently on hiatus. The original set of daily source code archives can still be purchased here for those that are trying to follow along. So if you want to watch the series and you want to pay for the source code and then try and work through it yourself, you totally can. It's just you're going to be looking at the videos purely on YouTube, which is what I do anyways. I never really followed the videos through the website just because I know how to use YouTube and I'm comfortable with it. We hope to have more info in the near future about whether we will resume the series or replace it with a newly designed one that provides the educational benefits people ended up wanting. Source code orders were never a significant source of funding, so if you were an early purchaser and don't feel like it was worth it, you can email support and get your refund. I do not feel like I want a refund, even if he never continues it, because there's so much material there. What I would think is a shame is if he like wiped out the series entirely and does what he says here, which is replace it with a newly designed one. If he wants to start a totally new series that has a more condensed sort of format that just kind of gets through like the most important things that he thinks are most important to share about game engine architecture, then I think that's fine. But to wipe all those 600 videos out to replace it, that would be a shame, because I've in the other repo that I have in a totally different language, I'm on like day 100 something, and I've learned so much working through just those 100 days. And like some of the material I'm most excited for is actually not until like day 200, where he starts getting into the GPU acceleration and all that stuff. Like I think there's just a ton. It's really dense, and it's up to you if you want to go after it and get that knowledge. I think everybody has different things that they are more interested in learning very deeply. And for somebody who wants to learn very deeply about how to make games using games programming, it's something that I'm pretty interested in. So I hope whether he continues it on as it where he left off, or he replaces it entirely, I'm looking forward to whatever he does. I'm excited that he's about to reboot it, because he hasn't done a video in like a year or two. Probably at least a year, might be closer to 2 years by now. So yeah. What was the reason for the hiatus? I think he just got to a point where he felt like he wasn't happy with the way things were turning out, because, and I'm assuming I've heard him speak about it in like random podcast appearances and stuff like that he's done, and it just sounds like he wasn't happy with the ultimate trajectory that it took, because he wanted it to be something that he would finish within a couple years. He when he started it out, it sounded like he envisioned finishing it within about 2 years, and then maybe he would tack on things that he thought were interesting as time went on after that initial release. But he just never got to that point, and I think he just wasn't quite satisfied with the overall direction the series took, because he didn't have like most software projects don't have like a perfectly good idea of what the end result is going to look like. That's a not uncommon at all. In fact, like 100 times out of 100% of the time, you never really know exactly what you're going to ship will look like, no matter how much experience you have. And I think he had a notion of all these things that he was excited about to go and build and show people how to build. And to that end, he succeeded in showing off a lot of stuff, which, I'll get to as time goes on. I'm hoping I can get to a point where I'm moving pretty quickly, because I'm still kind of learning Odin and translating from, C. A lot of it is 1-to-1, but like, for instance, here, he's declaring a nested array, and I guess I could just do a hard-coded array in Odin the same way he's doing it. I might just try and do that, but I haven't done a nested array like that in Odin, and I don't know that I care to try, because I think he's going to collapse it and make it one-dimensional here soon. But anyway, hopefully that answers your question.
I worked this out. I was kind of looking at past games and what their tile map sizes was, but we can adjust this in the future. But I'm just going to say, all right, I'm going to make a tile map. So basically all I'm doing is making an array that's 16 by 9. I'm going to reverse them here because this is the, if you look at the way C does its syntax, this is actually the one that gets packed together. So these go sequentially. The 16 goes sequentially.
What is this error telling me? If I try to build it, well, it's not giving me the actual error. There we go. The type of the variable tile map cannot be inferred as a type does not have a default type. Oh, well, does this not... I see. It's because I'm trying to instantiate it. There we go. Okay, that's what I wanted to do.
Sequentially, and the 9 is like rows. And so I wanted the X's kind of to go sequentially there. So what I'm going to do is I'm actually going to define my tile map right here as like a little, you know, as like a little...
Oh, no.
I guess hand inputted thing, right? 1, 2, 3, 4... Actually, why did I do that? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see. We can do it this way. Make it a little clearer. 12, 13, 14, 15, 16. Right? So here is a tile map. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So
I forgot that, I mean, he really starts off doing it as manually as possible, which is good for the educational side of it, but I was not prepared for this. I mean, it is what it is. We got to get through some not super interesting stuff to get to the parts that are exciting, right? So, I mean, do I even need to do this? It's all initialized to 0 anyway, but he's going to start filling it in. That's why, yeah, I have to do it either way. So, and what I mean by that is that Odin will just set the entire tile map to all zeros for me by default, because that's what Odin does. It uses a philosophy that the creator would consider or would call 0 as initialization, whereas if you don't initialize it, I mean, you can initialize it out to 0 in C, but if you just say I have this multi-dimensional array, and it's, you know, this many elements wide in the first layer and this many elements wide in the nested layer, but if you don't initialize it out to 0, you'll just have a bunch of gibberish in there, right? A bunch of random values that don't make sense. Is this right? Index 15 is out of bounds. Do I have an extra 0 in here? It doesn't seem like I do. Is it because, oh, I got the elements mixed up here, or I got the dimensions mixed up. Expected 9 values, got 7. Thank you, OLS, for telling me. Okay, good to go.
Oh. There we go. So this is our little tile map here, which I'm just going to hand input, right? And I'm going to go ahead and make something incredibly simple in the tile map. I don't know. I'm just going to do something that we would be able to see if it was working properly, kind of a thing. There we go. Something like this, where I'm just going to hand input some numbers that we should be able to then verify are sort of coming out correct when we look at the tile map at the end of the day. Okay? Right? Very, very...
Okay, just let him finish punching in these ones. So we're like filling in the tile map, right? We're just saying everything that's 0, there's going to be nothing there, and everything there's a 1, we're going to put a different tile down. Or maybe we will draw something at these zeros, but the point is the tile map is going to look different based on whether we put in a 1 or a 0. I guess it's good to think about, why can't I, oh, well, there we go. We'll go down 9, those all 1s. Again, my OCD is just forcing me to do it exactly the way he's doing it. There are certain things where it's like, I'm not going to implement that round by myself, but I'll copy verbatim what he's doing with something as silly as this little tile map. And I think that's pretty good. Yeah. We'll see when we go to output it. I know we got some ones over here. Goodness knows it doesn't really matter, But, you know, it's the second I stop doing exactly things the way as he does them that I wind up with some really nasty bug. You have an extra comma at the end of the tile map, do you not? So in Odin, trailing commas are a thing. In fact, I can show you what might happen if I try and compile this without that trailing comma. See that? Expected a comma, got a new line. Actually, you might not be able to see that error, but that is what this error is saying. I can try hiding myself. How do I hide myself? Might just, yeah, if I hide Casey for a second. So, and in fact, I can remove, I'm pretty sure I can remove this syntax error with my compiler flags, but I just try to use things as much in the convention of the way that Odin does them as possible. And using those same flags that I think, for instance, are used by like the Odin compiler itself, trailing commas are just a thing. It's the same thing in Zig, which I wrote for, what am I doing here? A long time. And so I'm just kind of used to that now. I know it looks a little bit funky though, if you haven't seen those trailing commas before. And now it's giving me a different error, but you can see it's not mad about that trailing comma. That's weird. Odin's weird. It's honestly not that weird. Of all of the weirdness there is to get obsessed about, that's one of those things where, for whatever reason, trailing commas have become more and more common at the end of, like, so another example would be like up here where I have some multi-line proc declarations, right? If I bump this over to a new line, it'll do the same thing and get mad at me that I didn't put a comma at the end here. And then it would work, but it's just, for whatever reason, this is the format I'm working with. I'm not sure what I'm happy about. Odin will not force you to do things that way, right? Like, you can take that compiler flag off and you can have no trailing commas if that's the way you want to do things, but those are just the conventions of the language, and I just try to stick to that. But I know that the creator doesn't care. He thinks that you should do whatever floats your boat as long as it's consistent with within your own code. You know, he doesn't think that anybody who uses his language should do things according to how he does them in the Odin compiler, in the Odin source code, right? That's just the way that he does them.
Very simple. So you can kind of see what I did there. I basically just spammed in some lens into our tile map.
In fact, I was not done because I have that error, right? What is this complaining about? I need to look at it. Show me the code, show me the error. Tile map declared but not used. Oh, okay, we just need to use it.
And now what I'd like to do is I'd like to draw the tile map to the screen as the background. So I'm going to clear it first. I'm going to clear the screen just to that purple as a purely debug operation so that I can verify, right? I can verify what's being written and I can see if there's purple showing through. I'm then going to iterate over my entire tile map. So I'm going to do the row of the tile map, right? I'm going to do the row, and I've got 9 of those. And then I'm going to do the columns, and I've got 16 of those, right? And again.
Now, I wonder how this works. So if we're going to go like 4 tile in tile map, like if we start in that first, how does it work with nested arrays? Can I actually do something like this for tile row? It would be like tile row in tile map. Yeah, okay. Just use your brain, James, and it'll come to you. We can do for row. We'll just do row. No need to be super verbose. And then we can go for tile in that row of tiles. And at least I think it's, yeah, it's going to be the row. And then, well, I think I can just make this a to-do and make sure that that compiles. And we can assign tile to nothing. And yeah, that'll work out. Okay. Just wanted to make sure.
And this is not This is just purely, like I said before, just exploratory code. I'm typing whatever I want in here. And when you are in this mode, and this is just really important to remember, when you're in this mode, anything goes. Do not think about code quality. Do not think about errors. Do not think about performance. Don't think about anything. Because the point of this code is to see what you would type in if you literally just had to do the thing fast. You just want to draw a tile map on the screen. So don't think about anything other than what is the easiest way you can think of to put that tile map up on the screen in a way that you can view, right? That is the only thing that you should be thinking about. You should never, ever, ever give even a moment's thought to any of the things that you see in those books that are like writing clean code and like how effective C++ policy. All that stuff should be completely shut off in your brain. Because what this code is for us to see what the CPU has to do in order to do the thing that we want. It's just to get it some notion of what the code has to do. And then we're just going to look at that after and figure out what the clean way to make it is, right? So you should be thinking about absolutely nothing at this point other than exactly that, exactly the how to get the thing up on the screen. That's it. So brain should be exclusively one track in that mode. That's all. Okay. So we have our draw rectangle function. So what we...
It's hard enough to be in that mode. Like, I can't imagine trying to just, like, you know, galaxy brain this and make some really elaborate entity component system or whatever from scratch. If that's what you want to do for the sake of doing it, then great. But like with no idea of what even what kind of game you want to build, like I can't do it. Not that smart.
We need to know now, and this is like this is our tile value, our tile ID, or whatever you want to call it. I don't know what we're gonna call it, but there we go. So we have a tile ID, and what I'd like to do is say, well, all right, we essentially want the color to be based on this tile ID because we don't have an ability to draw any sprites or anything yet. We haven't written the renderer, so basically we only have the ability to draw color. So what I'll do is I'll draw grayscale colors, and I'll have 2 of them, right? So what we'll assume that if the value is 0 in the tile map, right, we'll have a gray value of, let's say, 0.5, and if the tile ID actually is equal to 1, let's say, then I'm going to make it be white. So we'll have gray and white things in our tile map. Make sense? Seems
cool. So basically, if this tile that we got out of our map is a 1, then we just set gray to be white by assigning it to that full RGB value, right?
reasonable. All right, so then when I draw the rectangle, I'm going to need some things. I'm going to need the min x, right? I'm going to need the min y. I'm going to need the max x and the max y. So basically, I know whatever my min is, the tile width and the tile height, whatever we decide that those are, right? However big those are. I know that basically whatever the max x for my rectangle is just the min plus the tile, however big the tile should be across. And the same is true of the vertical extent of the height, right? So min x, min y, max x, max y, red, green, blue, and of course we're only doing gray, so I can just pass the same value for each of them. There we go.
Right. Okay, so plus the, what are we saying the tile width is? I guess we'll find out. And y plus our tile height. And then just drop all these coordinates in there. I guess I didn't need to break this call up quite yet. That was premature. It's getting pretty lengthy there. Like I bet something, yeah, something is blocking off there. It's still such a, I don't know. It's a different experience writing code with it this close to your face. I don't know if I'll ever get used to it.
So the only question is, what's our min x? Well, we know we've got a row value and a column value, right? And so for every row, we want to go, like each time that row increments, we're going to go down by one tile height, right? Which we already know is.
Okay, so that's a problem with my approach here. So we can say call, and we can say yeah, I'm going to have to actually make this verbose because we need to differentiate between the row index we're on and the row of tiles that we're iterating through. That's fine.
Going to be a value. So we've got the row times the tile height, right? And row is going to an integer, whereas all the rest of this stuff is float. So we need to convert that up to a floating point value. Again, see what I think we'll just do that for you, but I like to make it explicit so everyone can see that it's happening in the code. So I do that usually. And so also so that I know, so there's not weird mistakes. I find that if I do everything explicitly, I don't get caught by some weird C thing where it's like decided because of some rule in the spec not to do something that I would have thought that it should do. So basically, this is every column we know we're going to go up by a certain amount, and every row we know every row we know we're going to go down by a certain amount, and every column we're going to go over by a certain amount, and that's fine. And so what we might want to do though is start an offset. So we might want to make these start a little bit further in. So let's say we can say upper left x and upper left y, right? So there we go. So now what we need to do is actually find those values. Those are just constant values. Upper left x, let's say it starts at 10, right? So there'll be a little border around the thing. and 10. And then the tile width, I don't know what the tile width should be. We can certainly adjust it. Let's say it's 100 by 100, tile height, that, and we can recompile. And hey, there's our tile map on the screen, so that's pretty good. Oh, and I still got that other rectangle, which I don't need anymore. That can go away. So now we've got our tile map on the screen, and of course, we don't even have to do any math because that's the miracle, again, of hot loading. The DLL, everything gets...
Gotta pause Casey for a second so I can catch up. I can't go at 1.5 times speed in reality, so I gotta look all sluggish here compared to him. Even more than I otherwise usually would, just because, you know, I'm not him. What's going on with this call? What are you complaining about? Gray came out to be an F64 for some reason, so I guess that's just what the default float type is going to be in Odin. I guess I forgot about that. Okay. And then what else is going on here? So these, what did he type those? What type did he make the, those are F32s, and it wants an int. Is that the problem? What is this proc complaining about? Huh. Is it because, I see, these are all floats. That is not good. It's just like even this, all the spacing just looks wrong because the code is so close. I'm used to like the way the perspective is when the code is all pushed out and small and I can see a bunch more of it. Okay, so we're getting there. What is this error about? Mismatched types. So we've got the we're multiplying an int by okay. So these indexes here, right? That's what he had to do too. He had to convert them to F32s, and now I think we're good. Unless we crash, because we are indexing out of range. And that is in here. So I suspected that we'd run into something here. I see. It's because I don't have a guard to see if this offset is even within the bounds of the buffer either. That is not good. I guess just to do this really simply so I can move forward, we'll ask whether the offset is greater than the length of the buffer's memory, right? Because we can't jump into that slice beyond its length or we'll get that bounds error. Actually, we want to know if it's less than. So if it's less than, then we can get that row where we want to start writing out to the pixels. Otherwise, just don't draw that rectangle. Sweet. I don't know if that actually looks right. I think I must be, yeah, I must have done something pretty wrong here because I don't think that looks right. Hey, Nutella.
More that can go away. So now we've got our tile map on the screen.
Yeah, that doesn't look right. Well, first of all, his is red. His backsplash is red. Did he leave? He must have left that decimal in there. Not that it matters. Yeah, that doesn't look right. So either I punched in my values wrong, or I am I guess just any part of this logic could have been copied over incorrectly.
And of course, we don't even have to do any math because that...
Well, let's make sure that I'm doing things right, because I've got that code right up here in front of me. So if we've got a tile value of 1, he calls it a tile ID. We mark it white, and then we say the min x is that upper left x plus the column index times the tile width. Same thing for the y with the row index and the height. And then max x and max y are just the width and the height beyond the min x and min y. That all looks correct. So why am I drawing out something completely incorrect? Oh. It's because he's iterating. Right, he's going down in rows. Okay. I think this is all I have to do. So we're going... Right? Oh no, he is doing... Yes. Yes, okay, yeah. Right? Yeah. I don't know what I was thinking when I marked this as the column index and this is the row index. That was stupid. And it's column. Nice and verbose. There we go. Now we've got the same map as him. We're all good.
The miracle, again, of hot loading. The DLL, everything gets trivial. We can just do this, and there's our tile map is smaller. All right, let's make it a little larger. Okay, that's good. Maybe there. That's good. Let's say it should be 55 wide, something like that. A little bit bigger. Just a little bigger. 60.
Make a choice.
60? That's a little too big. So anyway, although you know what, if I actually just started it in the corner and didn't have that offset, right? You know, that's what you were thinking, right? I think that's our winner. Yeah. All right. So there you go. There's our tile map. It's on the screen, and of course now we can create. I mean, you can create a level if you wanted to, right? I could say that this is a standard dungeon map, which would look something like this. Let's go into insert mode there. If I want to make a dungeon map, now I'm making a dungeon map. That's always fun. We all know, right? Because Legend of Zelda set the bar, and now you see it all the time. Like Binding of Isaac, right? Looks exactly like this as well. Basically, you've got a thing around. You got walls around the edge, but then you have like a door, right, in the middle. And that might be a reason not to use 16 because we don't have a middle value, so we may want to use 17. You know what I'm saying? So there's our doors. We can probably make sure the doors aren't blocked, right? Let's make sure those doors aren't blocked. Don't block the doors, people. The player can't get in or out at that point. There you go. So now our player, you know, could walk in here, he could walk around, he could walk out that way, whatever he wants to do. But that's not centered, so that seems like a pretty obvious reason not to use that. So I'm going to go ahead and say that 17 is the magic value, right? I don't see why not. So basically, there's this extra row over here, right? If that makes sense, that we're going to push out there. Let's go ahead and do that. Oops, it's a little too much space, too much white space. So let's go ahead and push that out. Pushing it out. And then we can just say, all right, that's going to be that. So if that's the case.
Let me make this extra row, if I may. And then these can be zeros, right? I think that gets us on the same level as him. Oh, we got to update the dimensions. And yeah, looking good. Oh, I've got some extra tiles in there that I did not need. That's right, he was talking about blocking the doors and how that's no good. What good is a dungeon that you can't enter? Of course. Makes perfect sense. And then I did the same thing on the left there too. And yeah, of course now we're drawing it off of the screen, which I'm sure he'll fix in a second. I guess we got rid of that cyan square at some point, and I did not see that. I guess I won't delete it, I'll just comment it out for now, but I'm guessing that he just wiped that out. Awesome. The tile map has been drawn.
So then we also have to do, we have to figure out our offsets are going to be a little different here. So that means that, you know, the upper left is going to have to be offset by a little bit, right? Like that. So that essentially you don't quite see the whole tile because it wouldn't fit evenly. And the same is probably, you know, you probably want to do something similar. I don't know if we could. So let's say we did that. So you kind of only see half of that border tile. Then what we would want to do is we'd want to make it 10 wide, but that would make it so that we couldn't center our other guy. You see my dilemma. I don't know, do you see my dilemma? I'm not sure if you see my dilemma or not. I feel like we want the things to be square, but I'm not sure how I handle that. I mean, do I just do this so that basically this tile is always shown as a half tile? I don't know, something to think about, right? I'm already thinking about that. And again, like I said, this is why we do all this exploration, because I want to think about all these things up front before I make decisions about like what our tile map size is and all that sort of thing, right? Okay. So that's our tile map. I'm not gonna think too hard about it at the moment, but like I said, it's already putting thoughts in my head. Like I gotta start thinking about how I want to deal with that stuff. So I might go study old games, that sort of thing, to think about what the dimensions of this tile map should be. Now, one of the things that's interesting is it didn't used to be 16 by 9. Like Zelda, for example, was 4 by 3 aspect ratio, right? It was on the old TVs before HD went widescreen. And so I don't know, that may be a consequence of the fact that we're 16 by 9 now, that things get a little bit different. And we have to think about how we want to handle that exactly. It's something to think about. And so I would encourage everyone to put their thinking caps on there. Now, the other thing that we could do, right, is we could say that we have some kind of a gutter on the screen. I don't know. There's a lot of things we could think about there. And so I would encourage you all to think about them, maybe post your opinions, because this is essentially a design question at some level. And maybe think about those and what you think about them, essentially, because I'll be thinking about them as well, and maybe that's a good exercise to do. All right. So given that I've got this situation where I actually have a tile map on the screen, it seems like the next logical thing to do is to make a little player that can move around on them at a very minimum, right? Because we know we're going to need that. And so if I go ahead in here and I want to essentially add some storage for my player, just some really basic stuff inside the game state structure. Now, normally we shouldn't be able to really do much to structures while we're hot loading, but in this particular case, I think it'll actually work. And the reason for that is because there is no actual stuff in the game state structure. It's just the beginning of our memory block, and nothing else is stored in the memory block either. So if we just go ahead and start writing to those values, it just works, right? So I can do that, and nothing will break because there's nothing actually getting rearranged. It's just adding some stuff to the end, and so the hot loading, I think, will actually still work. So what I'm going to do now is I'm going to draw a player in here, right? And the player is probably going to be, I don't know, let's say that the player X and Y values should probably be, I would suspect, the player X and Y should probably represent some value that's at the base of the character. Trying to think of how to explain this. I might need a diagram for it. Just trying to tell you what I'm thinking here. So if I have a tile map on the screen, right, and I'm looking at this tile map.
What is this comment I missed here? It's basically Conway's game of life now. It will be what we make of it, I suppose.
Sort of as grids, and you know, I've got some notion of things like this is a wall, right? And these are filled in and I can't walk there. Well, normally what happens is the player's sprite, right, doesn't stop when the top of the sprite hits that wall. Usually what happens is they kind of eclipse the wall a bit, so their actual location is typically more about where their center of gravity is projected on the floor, if you will, right? Like usually the player sprite kind of eclipses the wall like this. It comes in front of the wall, you know? And so the position, if I was checking the position against the tile map in some way, I'm not checking the center of it, right? And I'm not checking the upper left corner or the lower right corner. I'm checking this sort of center of the bottom of the sprite in some sense. Now, we'll probably do something a little more. We'll probably make maybe like a little bit of a circle there for collision detection eventually. Who knows what we'll do? We're not going to probably literally just check a point when we're moving the guy around. But for starters, we'll probably just do that. And I want to do something relatively close to what I might actually want, so we can see how it feels when we move him around. So basically, right here is mostly what I want. So when I draw this guy, I'm thinking that what I want to do is say, all right, where I draw the rectangle, if the X and Y for the player comes in, you know, I don't actually know exactly what I want here, but I want something like the upper corner of the rectangle. We want to subtract the height of the player, right? So we want to subtract the height, and then we want to subtract half the width, right? Because this is the half line. And then we draw the player between there and the width height, right? So we kind of want to, this is our kind of diagram for how we want to draw that. If this is the player X, player Y, right? So really straightforward stuff here, but again, since this is the very beginning of our work with this sort of thing, I just kind of want to explain these things in a little more detail for people who've never done stuff like this before. When I do this stuff, it's like second nature. It's like, oh yeah, that would just type and like come out of my fingers if I start typing, right? But that's only because, I mean, like when I was little, I mean, when I was like 8 years old, right? I used to draw things on graph paper and input them into the computer for graphics because we didn't even have like paint programs or anything like this, right? And so a lifetime of doing stuff like this means you can just do it in your head. But if you've never done anything with graphics before, you have to actually think it through, right? And it's only after you've thought it through a bunch of times that it's second nature to you. It's like anything else, right? And so, yeah, if you've done this before, then you know what I'm talking about because you've got second nature. But if you've never done this before and you're like, whoa, you know, what's going on? As you do this more, it will become second nature to you. You won't have to sit and think about these things. You'll just be like, boom, and you've got it. But it does take a while to get to that point, right? Like, it's like having done it all the time. It's like riding a bike, right? You're just kind of like, all right, yep, I know how to do it.
That's exactly what I was talking about earlier, where it's like it just takes enough time and exposure and experience to where like doing a thing is just easy. this sort of thing, like I'm getting there, but I still can't, like, walking a 2D tile map, that's pretty straightforward. But if we're thinking about it in 3D space in particular, which he gets to eventually, he sets out to make a 2D game, but like with a 3D notion of space, so that you could duck under a projectile if it's going like above your midsection, that sort of thing. But that sort of thing, I'm hoping that working through the series in those first 100 days a second time in a different language will really cement a lot of that stuff, where it was just like I'm blowing through it. I'm like, okay, Casey, whatever you say, man. I trust you. I trust that we're going someplace awesome with this. But that intuition, it just takes time, and that's kind of what I've tried to remind myself, because there was a point in time where like it was not intuitive at all for me to just start writing a database schema and start hammering on all that data and shaping it into little blocks, the way that DHH put it, which that's all I'm going to say from now on when I talk about what I do. I hammer the data and I shape it into little blocks. That's just got to be the best description of making CRUD apps that I have ever heard. I mean, nobody has ever sounded so passionate about it before he went on that rant in that video.
And similarly, you know how to debug them. So you'll do the rectangle calc in your head, you'll type it out, and sometimes you're wrong, and you see the wrong thing, and you're like, oh, yep, I forgot the blah, and you do it right. So you remember some combination of how to always do it right in your head and how to correct the things you often do wrong in your head. It's real funny. You'll see it happen on the stream, I'm sure. I don't know if it'll happen right now, but it'll happen. So anyway, we want to draw the player, and I'm just going to do a player R, player G, right, player B kind of a thing. That, and so I want to draw a rectangle.
I forgot to switch myself over here. Player R, and these, of course, I'm going to have to turn into F32s, so there we go. And then we'll just, whoa, I did not mean to split my editor like that. That'll be B, that'll be G, that'll be R. Oh, well, it'll be the player R, player G, player B. And it's getting pretty lengthy. This actually wouldn't feel like it's too long at all if it weren't for the fact that this code wasn't so scrunched up into my face.
Of the player, I want a player width, right? Player width and a player height. And I'm not sure what those should be, right? I don't really know. I have no idea. I'm going to make them the tile width and the tile height at the moment, but that's probably a little too wide, because if he has to move through, you probably want him to have a little bit of slop when he moves through things. So, we could even say that it's going to be 75% of the width or something like that. I don't know. I'm not sure. Like I said, really don't know. So then what we're going to do is say, all right, when we actually go to draw this guy, right, I want to do player R, player G, player B, and I want to do the min x, min y is going to be our game state, which remember I did get up here. It's right here. So we pulled that. That's the base of our memory block. So it's going to be the game state, player x. In fact, I probably should do this player top and player left, that. So I'm going to take that player x, and like I said, I want to make the left of the player be minus whatever half his width is, right? So
do I just have it? What am I? Where's my state? It's because I assigned it to nothing, right? That it's not telling me that I have a game state. No, huh? Language server is goofing on me. It's not telling me that I have a game state variable up there. Whatever. Player left and then player top. Okay.
I'm just going to do half, right? Multiplying by 0.5 is half. We do half the width, move it back, and again that corresponds to this arrow right here, right? So I'm taking the x of the player and I'm moving it back by half the width. And then I want to take the whole player height here, and I want to go back by the entire player height like that, right? And so I'm going to go ahead and say player left plus player width, player top, oops, not top, that, player left plus player width. Don't know how that got in there. Player top plus player height, this. And so now I've sort of got basically, I'm passing the left and the top as the place to start, and then I'm passing for the
I did that wrong. Okay, I'm just going to pause so I can catch up with him. I just have to keep reminding myself that he is going at 1.5 times speed, so I can't feel too terrible if I'm falling a bit behind. But I am trying to zoom through this so that I can wrap up the stream, because I got to go here in a moment. Yeah, and then we go out from the top to the player's height. Just sanity check that. That looks correct. And yeah, let's back that out. And we might have a drawn player with that call.
That's the min x, min y. The max x, max y is going to be plus the width and the height, right? And that's the entirety of my player drawing code at the moment. Now, we don't actually know where the player is, of course, is also a problem. So the values that are in there are whatever the values were. So that's certainly a bit of a problem. Like the actual game state player x, player y. Well, I guess I could do this. Game state player x equals 10.0, something like this, let's say. There we go. And then you can see him up there, right? There he is. And now we're probably just going to need some way to move him around, so we can go up to our controller code. Again,
make sure that I have a player. It does not look like I do. Oh, did I make him the wrong color? It looks like I did. I did not bother to set the colors. Yeah, blue is set to 0. Here we go. And I see a bit of yellow there in the corner. I'm just going to assume that that's right. Yeah, that looks like what Casey has.
To move him around, so we can go up to our controller code. Again, make this a little bit bigger so we don't have to program in a little tiny window. We can go up to our controller code, which we had here. And I'm going to use the digital movement. I'm going to use the keyboard for now, because I don't want to deal with the analog movement at the moment. So basically what we want to do is say, all right, we have these buttons, right? And I'm going to say that I have a player X delta and a player Y delta. And at the end, I'm going to take the player X and the player Y, and I'm going to add those, right? Like this. Okay, so if my controller input move up ended down, right? And I'm just going to kind of do this sort of thing, right? So move down, move left, move right. I'm going to say that if move up ended down, then the player X is going to be, I'm sorry, the player Y is...
He's just zooming away from me in all of his 1.5 times speed glory. Oh God. I think we're getting pretty close to the end, so I'm just gonna plow through and get it done. I should have just, yeah. So, whoops, I did not copy that, right? And then move down, and then what is this? Move left. Move right. What is going on with these types? I have to declare them as not just plain old ints, because they are going to be floats.
Is going to be 1, and if it moved up, right? If he's moving up, it's negative. If they're moving down, it's positive. D player X.
I could have seen that coming, so yeah, let's just go ahead and say move up is we're moving backwards, yeah, so -1. And then D player Y going down is actually drawing further up in the buffer, so that makes sense. And then if we're moving left, then we're going negative, we're going right, and we're going positive.
Equals -1 if he's moving to the left, because he's getting lower in X, and higher in X, right? So I'm just going to do that for now. Should be pretty basic. That's game state. There we go. And so now I should be able to move my guy around. Yeah, there we go. So there's the dude, right? And he.
Can I move the guy around? It would help if... Well, it looks like I can't. We're using digital movement. And I think all of those if branches look right. So why can't I move you? I don't think it's just moving super slow. If controller is connected, we're just using the keyboard. So I wonder if we're just not getting in here and it doesn't think the controller is connected. I'm gonna test that real quick. Are we connected? Whoops. I do not have that imported, so I can just do that. Seems like we're connected, so I'm just doing something really dumb, I guess. So we've got our change in player X and Y. Oh. Well, because we're just setting it here. He must have moved this assignment at some point and I didn't catch it. Or maybe he just removed it altogether? Yeah. That must have happened. I bet if I comment that out, I can move around. Yep. Sweet. Yeah, I didn't see where he deleted that. But looks like he did. So I'll just carve that out of there. I'm glad that I can kind of realize what you are doing by looking at the code you're writing. Casey can make it a bit confusing sometimes. Well, I mean, it's the fact that you're looking at his code minimized, right? And he's talking through it. He's having to write this all out just from like using all of his experience, and all I'm doing is copying it, but it certainly cements it because like he'll say it and then I'll say it a different way. If you say the same thing in 3 different ways, 3 different times, eventually there's going to be some sort of understanding happening, right? And that's why they always say that the best way to master some material is to figure out how to teach it to somebody else, and there's definitely a whole lot of truth to that, right? But why is it backwards? If you mean the direction that the Y goes in, it's because, or am I trying to be here? The screen, as far as the way the pixels are drawn in the screen, Y actually is drawn downward because it starts in the top left corner. That's not true for every single operating system, right? But it is true for the Win32 API, and I don't know because I'm using a different platform. I'm using a different approach to writing the platform layer because I wanted to be able to run this on any operating system. I can run it on Windows. I know that. I can run it on Mac OS. I know I can do that. I just need to get a Linux machine at some point, which I will. I just don't know when, and I'll verify that it can run there. But it might handle the Y coordinates differently there. I'm assuming that STL just makes it all like universal though, and I won't have to worry about that. But if we were going to write, a platform layer that deals with Windows and deals with Mac OS and deals with Linux separately, you'd have to coordinate all of that so that your Y direction is going in the direction that you think it's going within the game code. Like once you get into the game code, you'd want to make sure that's the same everywhere.
And I'm going to add those, right? Like this.
And okay. I just backed up a bunch and forgot to move forward.
So there's the dude, right? And he's moving around. Now, he moves around pretty slowly, and that's fine. Not a particularly speedy fellow at the moment. Of course, I also don't actually know what our frame rate is right now because we're not even printing it out. And so we are going to have to do some stuff here in a second to think about how that should go. So, in fact, let's just do that right now because, hey, we've got a player sprite moving around on the screen. Let's think about that. So what would happen here if I did this? What does that actually mean? What did I actually just write? Well, what I wrote is I said that the player's X position is going to be updated by 1 every time a frame goes by and the D key is down, basically, what that boils down to, right? They're moving to the right, right? So because this is in pixels, essentially, right? All of this is in pixels. That just means he's going to move 1 pixel to the right every frame. Now, there's a couple of reasons why that's not such a great way to do things. One is because our frame rate now determines the speed that the person moves at. If our frame rate is 30 frames a second, right? If our frame rate is 30 frames a second, then he's going to be moving at 30 pixels a second. But if our frame rate were to jump up to 60 frames a second because the platform layer decided to run at a faster frame rate, then he would move twice as fast and the game would play twice as fast, which is not what we want. So what we want to do is we want to take the actual value that we're getting in here for the amount that we're supposed to move by, right? seconds to advance over update, right? I don't love that name. Second, I couldn't decide what I
Aha!
wanted it to be. Let's see.
I hated that
I'm
name
gonna call
too.
it DT, right, for D time. DT for frame. So the amount of time that elapses over the frame is what we're going to use. Excuse me. And so what I'm going to do there is I'm going to go ahead and multiply however much the value should be, however much the motion should be. I'm going to multiply whatever the movement direction is, essentially. I'm going to multiply that by whatever that dt value is, right? So that way I'm going to get a constant amount. So if the amount of time that has passed goes down, then the amount of movement will go down. If the amount of time goes up, then the amount of movement will go up, which is what I want. We put a little to do in here. There's stuff that I haven't talked about yet, and so I can't do some things that I would normally do here, but I'll mention what they are briefly and then we'll move on. Okay, so what I want to do is I want to take this dt, and I want to, that's in the input structure, right? I want to go ahead and multiply that out. So now we have a fixed amount per frame, basically. And of course, the problem with it is this is now going to be incredibly slow, because that means he now moves 1 pixel a second. These values are now in seconds because we're multiplying by that dt. And again, this is the dimensional analysis again that I've talked about many times.
Unfortunately, I have some kind of type thing. Oh, there's no... Oh, I'm accessing this off of the state and not the input is the issue. There we go. Thought it was a type problem. Still has no field. Seconds to advance over update. I need to go into the... Oh, God. I need to go into the main code here. The main package. That's how I should refer to it from now on. And target seconds. Where is that? It was seconds to advance over update. Yeah, I'm glad that I was like, that name is just a lot, man. This is a lot better. Delta time for frame. I like that a lot better.
Essentially what we have is we have a dt for frame, right? So for the frame, we have, this is essentially the number of seconds that we're going to have. So this is in seconds. This is some number of seconds. It's dt seconds.
So all the game physics are tied to the frame rate in this case? Yes, that's the goal, right? Because you want to... He explains this in more detail later on, I'm pretty sure. But the general idea, right, is that as human beings, we have an understanding of the way physics works, just like an intuition based on like existing and like looking at experiencing life. And like if you lift up a chair and if it's made out of something, a light material, it's easy to lift up. If it's a really heavy chair, it's hard to lift. Like there's just an intuition there. And basically the way he explains it is that if, as a player, even though you're playing a game and it's like not a real world, the way that you intuit how to have fun with the game and like understand how to play it and all this, it actually pretty directly corresponds to the actual physics that you deal with, in real life. And if you subvert somebody's expectations in a way that isn't very intentional, then it just doesn't feel good to play, right? And so by tying the physics to the actual frame rate of the game and locking that in, you get more consistency as far as that goes. Pluto Man, hey, thanks for dropping by. It's good to hear from you. Good to hear from you as well.
That we're getting passed in. So we're going to multiply. We're multiplying that by something. Right? We're multiplying that by a value, and we're getting pixels out. Right? We're taking the result and we're using it as pixels. So dimensional analysis works in reverse as well. We know that if we ended up with pixels and we started with seconds, we know that the thing that we're multiplying by, we can fill in the units, right? Pixels is on the top because that's what we ended up with, and seconds is on the bottom, right? So we now know that the value is in pixels per second. This is pixels per second, right? That's what we did. So if we're doing 1 pixels per second, that's just not very many. So let's let the guy move 32 pixels per second, let's say. Or you know what, we can do that in an easier way. We can...
Let me go ahead and jot that in there. We're moving at pixels per second, excuse me. And then what was he changing over here? Something about making it 32.
Basically say at the bottom, right? Let's give him some speed.
I see. So he's just, magnifying the rate at which the change in direction is happening, so that we're not crawling 1 pixel at a time. And that still looks pretty slow. We'll see what he thinks of it.
There, right? And off we go. Oops, where's my game? There's my game. Right, so now he's moving a little faster. It's not great, but it's faster, right? And why is my move up button not working? Do we have a bug somewhere? Oh, nice. Oops, sorry about that. Too many windows open. Where's my damn game? There it is. All right, so then the guy's moving around. Still pretty slow. 30 pixels a second is not very many, as you can see. Let's get him up a little bit higher. Speed of the game, maybe let's say that he should be at 128 pixels per second, something like that. Let's see how that is. There he goes, moving along. Wow. Although, you know what? I think our frame rate is pretty darn low here, right? Because look at how slow, look at how chunky that is. So maybe we might not actually be, if we're not hitting our frame rate, then this isn't in seconds anymore. We could change to passing the actual time that has elapsed, but that's unfortunate. So I wonder how slow we're actually going. So let's take a look. Let me go ahead and close this out. Let's take a look. Because we have to hit our frame rate, otherwise our timing values will be wrong. Now, the other thing we can do here is pass the actual time value that's going through. Maybe this is something we'll have to do in the Win32 platform layer relatively soon, actually, if you think about it. I got to fix the bug now in the platform layer as well. We changed this name to DT for frame, right? So there we go. But I guess our frame rate is pretty darn low, which is unfortunate. Let's take a look at what it actually is, just so we can see. Are we not actually measuring?
I somehow forgot about some of this stuff. I don't even know if I'm going to be able to enable the frame rate stuff here on the fly. I guess I could just go for it. Well, yeah, this is split out, right? So I think I can just... Well, I don't care about that. I just want to print out the frame rate here. Yeah, there we go. And I can just kind of see what I'm working with. And it looks like we're at 144 hertz, so we chop that in half and we're going at 72 frames per second. So I'm not seeing... Oh, that's right. He never fixed his FPS code, but for whatever reason I did. So he's getting zeros out there for the FPS, but I'm getting, 72 frames per second, which I expected to see 60, but I guess that my monitor changed its setting, so now it's using 144 hertz instead of 120, right? I am getting a blip in there somewhere. It just doesn't look as jerky like he was saying for me. I do see a little blip every now and then where it looks kind of funky, but we can kind of tag along with how he's doing things and see, because I don't know exactly what the issue is. But yeah, the beauty of software rendering, indeed, it's actually pretty impressive the state he gets it to just doing pure software rendering, and I couldn't believe how fast it was going when I wasn't running a debug build. When I was running like a release build with Zig, it was pretty awesome. I do understand that you have to have a certain tick system to tie engine updates to. The frame rate is pretty convenient. Anything you can do to make sure that frame rate is tied into what's happening in the game, like reliably, so that it doesn't ruin the experience based on whether you're at 60 FPS or 30 FPS is what you want. A decade of newer hardware probably helps. Surprisingly not that much. It does, but I don't, some of this is you can chalk up to, like, I wrote it in Zig, right? I didn't write it in C and C++, so I'm not sure how much of an impact that made, but I was able to get it running faster than his, and you probably could chalk that up to hardware, but it's kind of hard to say.
During the value, though?
But it's not, the difference is not as impressive as you'd think, because CPUs have not, the way that CPU hardware has gotten better in 10 years, and I'm a layman, so I could be wrong on this, but based on what I understand, the extent to which CPUs have advanced in the last 10 years is not to the extent that it makes software rendering, inexplicably faster, right? Because we have GPUs to do that. So nobody's trying to build CPUs that, are good for doing a lot of that wide math, right? That GPUs are just, that's exactly what they're good at. So anyway, let's go ahead and toggle over to Casey and see what happens.
Something wrong here? What are we printing out in milliseconds per frame? No, we're looking at get seconds elapsed. So I think I've done something. So we got a bug here, I feel like. Is that actually milliseconds per frame, right?
So you can see he set it to 0. He just hard-coded the FPS to 0. He's not actually getting 0 FPS. And I noticed that and actually just updated it as I was working through the initial platform stuff.
And that is actually being measured by the Win32 get seconds elapsed. So if we're taking 33 milliseconds per frame, we should be animating very smoothly, right? We should see something very smooth happening on here. And yet, do you see how jerky that is? Why is that so jerky? What's the bug? Does anyone know what the bug is? I'm not sure if they do. I certainly don't. So why is that so jerky? If we're getting a totally smooth frame rate, that seems wrong. So what's, like I said, I don't know what the actual problem is there. I would like to know. I suppose it could be, this could be the streaming thing again, but I don't know. I don't want to assume that it's just OBS doing that. And I guess I don't have a real way to test that, unfortunately. But I don't want to assume that that's true if it's not actually true. But it seems like we should be getting 30 frames a second, and yet we're not. What would happen, let's say, if I changed it to 60 frames a second as our target? I'm just curious. Let's see. So game update hertz is monitor refresh rate divided by 2. Well, let's just say that it's not that anymore. It's just by 1. Well, so that does seem awfully smoother. So I wonder if this is OBS is just messing with us. That's kind of
I can't help but smile all smarmy like knowing what his problem is before he does, but it's not like that sort of thing happens. It's like it's weird getting that sensation because I got so used to people commenting on how I would play video games, right, when I was doing Let's Play videos 10 years ago, and you get to a point where you're like, yeah, well, I mean, you play the game if you don't like how the way I'm playing it. But then he actually has people commenting on, like, same way people would backseat game me and everybody else that plays games on the internet back in the day. You have people backseat programming Casey, which is just, it's kind of funny how that phenomenon, you watch somebody do something and you think it should be done this way, and just, you know, inevitably somebody is going to have that thought and decide, oh, this is what you're doing wrong. I'm going to tell you.
Fortunate. I'll have to test that separately on the stream because we are hitting our frame rate as far as I can tell. It's actually working properly. And it does get smoother when we output faster, which means that could be because we're getting like a beat frequency. That's unfortunate. Yeah, you know, I guess maybe eventually I will have to go to using a capture card. I was hoping not to have to go to using a capture card for this sort of stuff because they seem kind of unreliable potentially. But it looks like I may have to. I kind of need to get things out of the equation here if that's the case. Yeah, you can see how jerky that is, and that's really annoying to me. Now maybe it looks smooth to you. For all I know, it looks smooth on the stream, but it looks very jerky to me. Is I guess all I can say. So yeah. So let's see if this holds water as well. We know how many pixels up and down we are, so I'm going to time how long it takes to get there. 1, 2, 3, 4, 5, 6, 7, 8. So it takes him 8 seconds to get, like, by my crappy, just me counting, right, which is not a particularly good way to do it. But if it takes him 8 seconds to get to the bottom, and our declaration was he was going to move 128 pixels per second, then we should expect, right, that it should be somewhere around there, you know, is the height of the window. And I was just counting randomly, so it could be more like 800 or something like that. But let's take a look at what it actually is, because I'm just trying to determine what. Yeah, I feel like that's way too long to get from the top to the bottom, if that makes sense. So I feel like I feel like there's a bug in here, is I guess all I can say. So I believe we said it was 540, right? So it feels like maybe that's twice as fast as it should be, or somewhere around there. Now maybe, again, like I said, maybe I was counting a little bit too fast, but it just feels off. It just feels off to me, and I feel like we've got a bug somewhere. But of course, it is the end of the stream, so I guess basically, note Casey, I should say to do Casey, let's take a close look at timing tomorrow and try to verify that it is working properly, because it appears that things are moving half as fast as I would have expected.
I don't know if that's actually a thing. I'm just going to add that to do on my end as well. Or because I know he had like issues with the streaming software at various points, and that can kind of mess with the frame rate of what he's seeing, because it doesn't look as bad as he seems to feel like it looks. Like, I'm watching it back on the recording, and it looks like 30 seconds per frame to me, or 30 frames per second, I should say. 30 seconds per frame. Now that'd be terrible. Okay.
Right. So I think that's our to-do for tomorrow. All right. Excuse me. All right. So now it is time to go to the Q&A, and
that's perfect. I needed to wrap this up because I think Chelsea is outnumbered right now, and it's not fun to be outnumbered. by a bunch of small children. They will take advantage. I feel like he made the map smaller. Did he not do that? Oh, I see. It's just that his the outside of the bounds of the map for him are not cleared to black by default the way they are on my end. So it looks like he's just got all walls filled out beyond the tile map, but it's just defaulting to fill white on his end. I miss hideous purple. Well, I mean, I can add that back in for you if I can remember what the color values are. We can just make the whole tile map hideous purple just for you. Yeah, actually, this is kind of tricky because he just hard codes the gray, but I guess we could just pass them in as RGB. Just to have fun with it, because I think part of the fun of this, of me programming alongside him and going along with the stream, is that I can just do what I want to do with the code, right? And I can fool around with it and have fun. And we're gonna make it purple. RGB. And there you go. We have our hideous purple back in the form of a tile map. Great stuff. Well, I'll save the Q&A for tomorrow. I'm not thrilled about the fact that I've got Q&A from the previous day, and then I'm doing the whole code for the next day in the same stream. I need to like roll it over so that I can map it to just each stream that I do. I get to knock out one day, but again, I don't know how realistic that is, because I know, especially once I get into like the really hardcore stuff with like drawing sphere normal maps and all this stuff, it becomes pretty challenging to make sure that I'm not, you know, rewriting something or translating something that is just completely wrong, and then it takes a long time to unpack what I did wrong, and then, you know, it could take me multiple streams just to make it through one day, but we'll see. We'll see. So thanks for hanging out, everybody. I'm still having a lot of fun. It's good to get past all of the whiteboarding and start writing some actual code here and making progress, getting that first tile map in there, and we'll just keep on working through it from here, and we'll see where the future takes us. I might do something different on Fridays. I might try something different tomorrow on stream. I'm not decided on this yet because I really want to keep working through the series, but I might do something else where I just kind of go and look at some, you know, software industry related news and just kind of see what's going on there, educate myself on what's happening inside of my field, or just do like a different thing. Like one thing that I really want to do is get a debugger set up for working with Odin. You can see that the few times that I've run into something so far, I've had to print debug it, which I come from the web programming world, so that's just what I'm used to. Not always do I do that, but a lot of the time it's just like throw a print statement in there and then see what the hell happened to that data that just came back out completely wrong or got passed into something completely wrong. But because it's supposed to be pretty easy, I know a friend who's also been learning Odin, and he was able to get a debugger set up pretty easily, he said. So I might take a stream and do that. I don't know. It just kind of depends on what I feel like I want to do. I might just keep, now that I'm in this groove, I might work through like another week on the handmade stuff, and then we'll break off and just maybe do something a little more unique on Fridays heading into the weekend. Print debug is goated. I mean, it's worked for me for like 90% of my career. I have never had the luxury of using a debugger, but I can obviously appreciate the power of being able to use one. And so if I can, and especially because it's supposed to be pretty easy to do with Odin, I just feel like I owe it to myself to develop a bit of that experience working with a debugger. So that will be it for today. Let me just clean up some things that I noticed I was not happy with the way I had formatted some of this stuff. Was that it? I thought there was something else. Something else I was looking at it and I was like, I don't know why I did a line break there. Whatever. I'll figure it out off stream. Have a good rest of your